Hi, welcome to day two of the SEI Research Review for 2022. Hopefully, I'm welcoming you back and you were with us yesterday. If you weren't, I'm going to cover a little bit about what we did. And yesterday was really about our research work in bringing AI to mission. So the SEI does a lot of work in AI engineering and applying new AI techniques to the DoD. And if you missed it, you missed some great talks by Dr. Hine on AI engineering for uncertainty, Dr. McMillan on how to bring inference engines to portable and high performance for the tactical edge, Dr. Lewis working on automating mismatch detection so that we can deploy AI systems more successfully, Dr. Gallagher, who worked on deepfake detection and machine learning to how to do that, and Dr. Lau, who worked on AI evaluation methodologies for defensive cyber ops. It's not enough to just have some good AI algorithms. We also have to get those algorithms in a usable and deployable way for the DoD. And so if you missed it, I encourage you to go look back at the recordings when they become available. I just want to give everyone a heads up that we're experiencing some network issues today in the Pittsburgh region. We're doing our best to kind of overcome that, but you may see a few bumps and hurdles along the way. And hopefully we won't lose any of our panelists for our next panel that's coming up. And I'm going to pivot kind of right into that. So the panel that's coming up is on, look at my notes. It's Transformative Gamification. I'm making an impact across the federal workforce from cyber readiness to AI. And I want to be clear here that this is a panel. This is not a kind of recorded talk as it was before. So we're really looking to have this interactive. So I want to encourage all the visitors out there that we have watching this to interact with us. Ask questions on Discord, ask questions on YouTube. We promise that we'll see them and take a look and try and work everything into the conversation. I would encourage you as the MC, since it's not my panel, to see how much you can get the panelists to talk about your questions and engage that way instead of let them get through any kind of presentation that they might have prepped. So I'm challenging all of you to kind of make that happen. As you can see, we have some great panelists here. I'm not going to kind of read all of this. You can. Rotem is a research lead. He's been involved in kind of various parts of research across the SEI for many years and really is very, very passionate about gamification. Dr. Hammer, as you can kind of see, she's a professor with the Carnegie Mellon and then the Human-Computer Interaction Institute and the Entertainment Technology Center. And so, deep expertise in this area. And Dominic Ross is someone who works across our media and kind of capture. So, how do we do gamification and make it real, have the quality there? What are the technology capabilities of kind of doing that? Really helps with that, works on our kind of multimedia research and also a longtime collaborator of Rotem, so he's also very deeply involved in gamification. And so these three are going to, kind of really focus on what does it mean to have that transformative gamification? And you're going to see all sorts of kind of cutting edge and techniques and what's, kind of out there on the research side. I would absolutely ask them, kind of questions about readiness and, when do you think soldiers can really make use of this? What about the kind of generating force as opposed to the tactical force? And so with that, I'm going to pass it over there. And by all means, again, please ask questions and excuse us if we have some network issues and you might see that some of the participants become kind of a headshot as opposed to kind of a live person. That we're doing that to preserve the audio so we can still have a kind of a good audio stream for the conversation. And with that, I'm going to hand it off to Rotem and Dom and Jessica. Thanks, everybody.
Thank you, Chris. So yes, thanks for that warm introduction. The three of us are going to be focusing our discussion today on transformational games. How can we create experiences that change our audience in a meaningful way, change their behavior, change the way that they interact with whatever the topic at hand may be. I just want to very quickly make sure that you're familiar with all of our voices at the very least. Jessica, if you could say hello.
Yes, hi, looking forward to speaking with you today.
Hi, and Dom.
Yeah, great to be here. Glad we're getting to talk about gamification again here at the SEI Research Review.
And we have a lot of material to cover, so I'm going to jump right into it. That being said, please give us your questions, your comments. We're more than happy to discuss what interests you. So that being said, let's jump right into, we had a couple of different topics here that we wanted to cover, one of which is hands-on experimentation. This is one of the areas where DoD has some of its longest history in applying techniques from gamification. Since the 1800s, DoD has been conducting war games of various types. And one of the benefits of war games is you get rapid feedback, you get to iterate on experimental scenarios, different techniques, tactics, techniques, and procedures, different hypothetical, even weapons platforms, whatever the case may be that you want to investigate. It's a very low cost, very accessible way in order to try out new doctrine, new techniques, whatever the case may be. That being said, as we move towards the modern era, with a lot of the new capabilities that we've been bringing to bear, there's been somewhat of a divide forming in the community that we feel here at SEI is almost unnecessary. There's essentially two broad categories of wargaming that have grown out. One is a data generating, heavily analytical activity where the bounds are very tightly constrained. There is a heavy analytical backing to each resolution, to each step that's going into it, and a lot of computer modeling involved so that you can generate data, create analytics, really determine what you think the outcome is gonna be. And then you have this other almost the term bogsat gets thrown around a lot for a bunch of guys sitting around a table. We're obviously not advocating for that, but that being said, there is this explorational side of wargaming, this interactive side of wargaming, where you bring the humans into the loop, you allow them to express their creativity, you're able to actually try out new things. And this is where real revolutionary changes can get discovered, where there's a lot of value here. However, that doesn't mean that you have to give up that analytical rigor. And the techniques from gamification are exactly the way that you can bring that analytical rigor with you and still allow the expression of that creativity. And so that we feel very strongly that these two are not mutually exclusive.
So, Rotem, essentially what you're saying is wargaming kind of provides that sandbox environment to better educate not only the participants, but also leadership as they go through these examples,
Yeah,
right?
absolutely. It's usable at every level, and it's most useful when you're actually spreading it across the different levels of the enterprise, so that the war game exercises that you conduct at lower echelons can bubble up and provide the data backing, the support to experimentation at the higher levels, so that you're still talking about reality. We don't want to divorce ourselves from the real world, even if we're stepping into the near or even farther horizons of the future. We want to make sure that the data that we're getting out, the results we're getting out, are realistic, but at the same time we want to allow that room to explore, to try something new, because otherwise you're just going to get people that get together and then reinforce their previous prejudices.
And so, I think one of the places where there's real opportunity is not just sort of bubbling up the results of the games, but actually thinking about the process of designing the games. That when you're making a game, you're making a hypothesis about reality, you're modeling a future in some way. And so there's the opportunity not just to learn from the process of gameplay, but actually to pair experienced game designers with people who have deep domain knowledge, especially if you're trying to imagine some possible futures, to test hypotheses, not just about how one vision of the future might work out, but actually to look at multiple possible visions of the future and compare across different models to understand directions that of scenarios that people might face. at the same time developing the human capacity within the organization to better and better articulate those models in the form of games.
And growing it natively within DoD, I think, is one of the key things that, we love to work with our partners in order to enable them to develop the games using the frameworks and the tools that we create, for the very reason that there is a lot of value lost when you go out to an external provider for a war game that they've created, because you're essentially living in their mind, in their preconceived notions of what that war game should entail, instead of being able to allow your staff to go spend that mental effort to understand what they see the future of the fight is going to be, how this should be conducted, leveraging, experienced designers so that the game can be conducted in a useful manner. But when you source it to these commercial providers, you're getting their prejudices baked into the system, essentially, and so you're limiting yourself on how you can explore.
Well, and it can't be understated that there is a substantial financial investment into wargaming, from staffing, the running of the actual competition or game itself, as well as any type of scenario that's created. So one thing we want to make sure is there's reusability, and that's where gamification really helps with that.
Absolutely, and that's another really useful tool for some of the frameworks that we've created, where if you want to make modifications to it, you always want to ensure that those modifications are low cost. If you want to try something new, if you want to experiment, it's great to provide that sandbox where that environment allows for it. I see here you're showing one of the solutions that we've provided in the past, which was the cyberkinetic effects integration system, where we connected our existing cyber range capability to a kinetic battlefield simulator in order to allow for joint forces training and experimentation, so that we could actually have our cyber operators, supporting a real world, kinetic operation, so that they, and all the constraints that are involved in that, and so that they could experiment. Okay, yeah, we could do a cyber attack and take out the power grid here, or we could have a team drop a satchel charge, on the power substation. You're still going to get a blackout either way, but what does that affect? What does that inform? How much more prepared and alert are your defender is going to be after something blows up versus the power just goes out, right? And so it really lets you iterate on those scenarios rapidly and see what works, what doesn't, what are the implications. Because for a lot of the community, sometimes those new techniques, those new capabilities that are coming on board aren't as trusted. They know what a satchel charge is going to do. They know that after that satchel charge goes off, that power will be out and it will stay out. How reliable is the cyber attack? How much attention is it going to draw? These are factors that aren't as well, or at least weren't as well understood. And so you're able to do that experimentation and you're able to iterate. And that quick iteration with that quick feedback is one of the key aspects of these simulations, because I will tell you, when we ran this particular scenario, two outcomes from it that I think were very informative was, first of all, when we developed it entirely in-house, the first piece of feedback we got when we showed a very, very early iteration of it to our DoD our experienced partners, was you guys need to stop watching movies. Nobody's conducting an operation this way. And that we were able to bring in that expertise and create a scenario that really reflects the way that the Department of Defense would address a situation like this. And then not only that, once we put the real operators in that environment, those teams, every single team failed on the first attempt. Nobody succeeded. But it was with that iteration, with that experimentation, that they were able to refine their plans, refine their ability to go and conduct the mission. This particular mission was a hostage rescue mission, but they were able to rescue the hostage, get everybody out alive.
Yeah, but we learn a lot by failure, right? Right, Rotem? I mean, I'm sure Jess can talk about the practical application of failure within gamification techniques.
Oh, yeah. One of the most important things games do is they change the way people fail. The way I talk about it with my teams is we talk about failing gloriously, or how do you fail in the way that helps you maximize your learning and your learning outcomes. So with that, actually, we can maybe pop back up to the different approaches that we can use for gamification.
Yeah, so if you go to the top right one, I think you're yep.
Yep.
So
That's right. Increasing receptivity.
and
So
go ahead.
oh, great. So we know that not everybody responds well to failure. For example, when people fail in a training exercise, even if there are no formal consequences for that, people can become defensive, right? And they can blame their teammates or blame something about the situation instead of asking, how can I learn and improve? So one of the things that gamification can do is they can actually change the way that people respond to challenging situations like failure. They can so for example, when someone fails in a game, their response is often, oh gosh, let me try that again with a better strategy, right? Let me see if I can figure out a way to solve this problem. And we see people doing things like asking for help, expressing ignorance when it's about failure in a game. When if it were, for example, failure in the workplace, they might be much less likely to do so.
So to give an example from our experience, when we have personnel that come in, and this was a while back before we started exploring these techniques, we were doing our best to recreate the exact copy of their environment, make it as accurate as possible to replicate their office environment. And then every time we would get the same complaints. This is different. This is different. And what became apparent is the perception that they were having wasn't, because this was personnel that were already in the role, not preparing for the role. Their perception when we said, hey, here's a better way to do that, what they didn't hear is here's an opportunity to improve. What they heard is you're bad at your job and we're going to tell your boss. And so instead of listening to it, being receptive and improving their capabilities, they would start getting defensive. They would latch on to any differences in the environment that they could find as excuses. And the one that I always give, because it's as close to as the sun was in my eyes as I've ever heard, is, oh, the background on the desktop is a different color and the alert is the same color as the background on the desktop. So I didn't notice it because it blended in, but they would have been different colors in the office.
Yeah.
There's a certain point where you realize these aren't, valid criticisms. It's their defensiveness. And that's when we switch to using semi-fantastic settings. We put them in a role that isn't their real role, but still exercises the exact same skills, the exact same techniques, the exact same systems. But now you're not you're special agent, whatever. You're not fighting your normal day-to-day engagements. You are resisting an alien invasion. You are stopping a mad scientist, whatever the case may be.
And as you talk about that, Rotem, actually, we got our first question from Jason off of YouTube. Does gamification disconnect people from reality? If so, is that viewed as a negative or positive?
Yeah.
So I think the key. Go ahead.
I was just going to say, as with most things with games, this is not a question with a yes or no answer. That gamification can distance you to different degrees and in different ways. So, for example, there's a body of research showing that just thinking about yourself in the third person versus the first person can help you reflect on what you're doing and change your strategies and be more distant and less sort of like caught up in your own emotions. Gamification can do that, right? Just moving you from first person to third person. It can narratively disconnect you in the sense that Rotem was saying, right? Oh, well, you're not yourself. You're, you're a super agent, but you actually have the same job you currently have. And different strategies have different benefits. So, for example, when we put people in semi-fantastic situations, we know that it helps them let go of their ego because the situation is giving them positive reinforcement of you're cool, you're special, you're valued, you're part of a team. And failure is normal in this context because everyone involved is failing, right? So it can be a powerful tool. If you execute it badly, right, it can not work very well. But part of the sort of vision and the reason why we wanted to have this panel is to make the case that there's a role for craft in aligning the benefits of whatever gamification techniques you're using with the goals that you have for your mission. And now I'm going to point back to Rotem because he's going to tell us about this video.
Oh, yes. So this particular video is of one of the first iterations that we actually made of these semi-fantastic settings, and it's getting to exactly the point that you were making, Jessica, of you can't just apply gamification in a willy-nilly fashion. It has to be done in a thoughtful manner. I've seen far too many times when people slap a leaderboard or badges on something and call it gamified. At the end of the day, what you're trying to do is match your needs to the techniques that you're applying. One of the key things that we look for in the way that we create our gamified environments is that the tools, the techniques, the things that you're actually going to do match what we are trying to train you to know how to do. And in order to do that, we ensure that you get positive training value and not have negative training value. We try to replicate the experiences both on the social, like who you're interoperating with, and technical levels, so that you can take that experience that you've had in this semi-fantastic setting and natively transition it back into your work role.
Yep. And
so I see we have another question coming in from Discord this time. Asking if gamification results cross over to updating ML models and the TNE strategies, especially considering modeling and sim techniques. Well, I'm glad you asked that. Dom, can you jump again back? I apologize for jumping all over this presentation, but as we said, we are absolutely looking to answer your questions primarily, and jump to the Hades material. I believe that's under the improved teamwork heading. I think it's like the last slide on that one. So we've actually done some work in that area. Yeah, one more slide down. There you go. So this is the human AI decision evaluation system. This is a gamified environment that we use to actually test the output in this case, rather than just creating trading data, but test hypothetical output of AI-enabled decision support systems, so that we could actually run humans, real humans, through a gamified environment where they would, they had a narrative, they had decisions that they were making in context, and then receiving different support from various possible AI decision support systems. And the key part is we designed the system such that you could, after you've developed the system, pull out the hypothetical part and put the real system in and still use the same game. Continue iterating through it and see how it affected people's behavior. And one of the things that we had some surprising results there when we found things that, we as, AI researchers, we have a decent understanding of what's going on in a model behind the scenes. When we see 98% confidence on a recommendation, we think, oh, the model's pretty confident in this result. It turns out when you take a general audience and they see 98% confidence, they don't think, oh, as opposed to no confidence measure provided, if there's no confidence measure, they're like, oh, it says yes, so it's yes. If they see 98%, they see, so it's not sure. And it's not the result that we expected from that interface, and so we're able to use these techniques to collect the data that goes into developing the next generation of recommendation systems. The same goes true for creating training data. You can absolutely collect data from run-throughs of various gamified environments to get the data you need that might be either dangerous, expensive, or otherwise prohibitive to collect in other methods for training your data.
And actually, I'll add that one method for collecting training data is actually two slides earlier, right? We showed a screenshot. We were talking about this in the sense of how do we get large teams to coordinate effectively. There's what's called game sourcing techniques, right? Where you have lots of people playing a game together and the total contribution is creating some kind of knowledge or some kind of data. So next slide. What we're looking at here is a game called Fold It, where I think they had 57,000 co-authors on a scientific paper that introduced new protein folds, because so many people contributed online by playing the game. And this is an approach that we can use to generate data sets as well, right? So let's say we want to create a machine learning model, but we don't have an appropriate data set for training, we can actually use these game-based techniques to get appropriate data from people who might not otherwise contribute their data to this kind of effort. And so my research group, one of the things we work on is actually new ways of using games. For example, looking at game streaming as ways to get people to contribute data to data sets that otherwise we might not have access to, and then our models might be trained on a data set that leads the model to make mistakes because it has whole sort of groups of data missing.
And so one of the things that I wanted to note here is an excellent, very relevant right now is, GIS ARDA, right? So this is a homegrown capability being used, in Ukraine right now that is actually, it's not, I don't want to call it gamified, of course, but it is allowing us to coordinate these large teams and these distributed capabilities in a method that we can leverage. It has direct applicability to DoD use cases. I do see that we do have a follow-up from, was that YouTube?
That was from YouTube from Jason, that's right.
Yeah, so Jason had a comment in response to our discussion that says, that makes sense. As a gamer myself, people always try to exploit game rules instead of being present in the game. Sounds like these are curated experiences to avoid that scenario. So again, Dom, if you could jump back to the title slide and go to we're going to be jumping all over.
This is how we're proving we're live, right? This is not canned. Yeah, exactly. We're talking to you.
Well, if you could go to align incentives, because I want to make the point, Jason, that the way that they always try to exploit the game rules isn't limited to the gamified experience that we've created, and actually the gamified experiences can fix that problem. So the comment I always like to make is you get the behavior you incentivize, not the behavior you ask for. You can ask for something until you're blue in the face. If your incentive structure doesn't match it, that's not what they're going to do. And the classic example here is actually with rules of engagement. We can come back to the slide afterwards, Dom, but I just want to jump ahead to the synthetic client help desk slide, if that's okay. Yeah, perfect. And so we actually used cheating as a benefit. So we had the case where we had repeated exercises with DoD personnel that we would provide the rules of engagement and then score on something unrelated to the rules of engagement. Essentially, we would say, defend this network, and here's all the things you're not allowed to do in defending this network, and then we're going to score you on, even though these things would be really effective for you, but you're not allowed to do them because it would mess up the exercise. And then what are we going to score you on? Whether or not you got compromised. So what is the first thing that they would end up doing? Whether intentionally or otherwise, they'd end up doing some of those things that they weren't supposed to do because they're just trying to secure their network. And so, we started thinking, oh, they just don't understand the rules of engagement, or they don't, appreciate it. So we're going to give them a quiz they have to answer correctly before they can even start the exercise. Again, what they do, they violated the rules of engagement. But what happened when we changed the evaluation criteria, we aligned the incentives. What we did is we created the system called the synthetic client help desk, and we distributed thousands, tens of thousands actually, of automated fake users into the various enclaves that they were defending, so that now it wasn't just some random network. It wasn't cyber for the sake of cyber. It was an actual mission they were supporting. But the real innovation there is that we then instrumented these fake users so that when something broke, when they couldn't edit a document, or an email they were waiting for didn't come in, or whatever the case may be, what did they do? Same thing a real user does. They picked up the phone and they called the help desk and opened a ticket, or at least what we would hope users would do. But we created an automated ticketing system that would then triage these tickets dynamically and put them in the environment. And now what happened, and the key insight, is we made that part of the scoring. Keeping your number of open tickets low is part of the scoring. And now when they go and push a blank application whitelist so that literally nothing can run in the environment, instead of getting a perfect score because you never got compromised, your score starts plummeting because nothing can work and everybody's business has ground to a halt. All of a sudden now they're super conscious about making sure that they're maintaining the ability to achieve the mission while still defending their networks.
Yeah, we got a great comment here actually from Discord that kind of echoes that, Rotem, which is, you get what you incentivize, measure, and reward.
100%.
And I want to actually amplify. So Rotem's example here is talking about behavior that's fully within the game, right? Fully within the simulation. How did they change their behavior? some of the work that my research group has done is looking at how people change their behavior outside of the game in order to get better at the game for this kind of like cheating as a benefit. So for example, we worked with a group of role players who played a game called Ars Magica. It's set in the 13th century. And I was really interested in their play because they would all, with the exception of one person, I interviewed them, they said, I hate history. History is really boring. I said, okay, well, what did you do this weekend? Oh, I went to a local university to read about 13th century baptism theology. I said, is that history? They said, no, that's playing the game. Okay, that's how you play the game, right? And they were doing this on their own time because they wanted to get what they wanted inside of the game. So I think that there's a lot of power here that isn't just about incentivizing, measuring, and rewarding within the frame of the game, but also changing the way that people think about their learning activities and their commitment to practice outside of the game itself, and getting them to do things that they might not otherwise do independently and take initiative.
Yeah, Dom, could you actually go back one slide to the one that we skipped? Because Jessica, you bring up an excellent point. Is I talk a lot about incentives, and all too often when people hear incentives, they think payment.
Mhm.
And what we're really trying to get across here is that we're not talking about payment here. We've seen in our research that payment is actually one of the worst motivators. Once you pay somebody enough that their basic needs are met and they're comfortable, additional payment isn't very motivating. But the things you can get out of people when they're emotionally invested in a narrative, or when you're speaking to really anything that's a core motivator to them, be that competitiveness, cooperativeness, caring for the success of the rest of their team, getting recognition or status. There's a lot of these different motivators that you can key in with your gamification techniques. You can key into those motivators and get them to invest of themselves during their free time, nights, weekends. This is really the way you can stretch your training dollar in a manner where you'll get a lot more out of your audience when they're engaged, when they want to do it. The example I think that you gave in one of those research papers I read was with Civilization. And so there's the classic meme of like, oh, just one more turn and it's morning. I'll be honest, I've developed lots of cybersecurity training. I'm certain I've never had one of my students in an ungamified training stay up until morning, accidentally studying cybersecurity material. But you can absolutely do that when it's a cybersecurity game that you've created, and they just continue consuming that content because it's engaging, because it's rewarding in and of itself.
So it's all about boosting that production through intrinsic motivation to actually encourage that state of flow, right? So the mastery of skills happens through the exploration of the content, through somebody's own time outside of the normal training operation.
Right. And that can give them other kinds of rewards. So again, I run a research group that studies this kind of gamification and transformational gaming. So we do studies. We ask people to play our games in real life conditions. We ran one study where we said, okay, we'd like you to play for 20 minutes and give us some feedback. And the person actually played for 5.5 hours. And we talked to them about why. And they said, well, it was meeting a need that I had at the time. I mean, they didn't articulate it that way, right? But they were looking for something to do with their friends, with their community. And the game happened to sort of fit, right? It's not like we tricked this person into playing for 5.5 hours. It's that the game met their needs for something that they couldn't get any other way. And that's one of the things that makes games so powerful, is that it's a way of delivering rewards that are not just about getting paid.
So we have another comment that came in from YouTube from Claudine. Very interesting. This could certainly change attitude of students towards assignments and keeping up with reading lists. So actually on that topic, Dom, could you go back to the last slide on the hands-on experimentation portion? And so this is actually speaking of students and getting them motivated and engaged. The last slide, Dom. There we go. Perfect. This is actually a cybersecurity and risk board game that was developed here that requires no prior knowledge of networking, programming, risk assessment. I'll be perfectly honest, my risk assessment class when I was in grad school was the class I hated the most, and I had the most trouble keeping up with. And this is actually a game that was developed targeting 6th through 8th graders that ending up getting used across graduate programs, trainings for C-suites, all over in different areas, because it didn't have that prior knowledge requirement. But at the same time, it allowed you to recreate organizations from all sorts of different sectors, be it critical infrastructure, entertainment, banking, whatever, or a school, whatever the case may be, and then actually have a meaningful discussion about how do you balance risk, how do you invest in your organization and securing it in that environment. You don't need a computer, you don't need any prior knowledge, and you're able to actually have that meaningful discussion there. But the key part is what happened after, is that the students would take these cards that have these little snippets on them, and then they would independently go and research more about what is this technology, what is this doing. Now, I guarantee you that a group of 6th graders did not fully comprehend with all the nuances of the difference between a inventory management program and doing audits, but having them hearing them in class next time, having an argument over which one provides more value to their organization is incredibly informative, when you're realizing that 90% of the argument they're having isn't on those cards. They went home and they went and did additional research on this. They invested of themselves, because why? They wanted to win next time in class.
Yeah, and and I think the thing I want to amplify is that that's an approach that can create a really powerful sort of cybersecurity pipeline, right? But it's something that we've seen work with kids all the way up to adults, lifelong learners, and so this is something that can be used for example, ongoing professional training, professional development, thinking about helping people meet their professional goals. And I see we have a question in Discord, right? Is like, how much is too much, right? How much can you use gamification to modify people's behavior in their free time before you start running into ethical issues? That's a huge question. And there's some research on this out of University of Pennsylvania, actually, that game players know when you're trying to manipulate them. And actually, as people play games more, they get better at knowing when they are sort of being exploited. So the way that I would think about it is that if the game is providing a context that is giving value to the player and you are getting value back, that's a peer exchange, then you're using games and gamification appropriately. When people are only participating, for example, because their boss tells them to, then you're not going to get the benefit of games, right? And so you may get the behavior modification, but you've kind of left the sphere of gamification and gone more into the sphere of like,
and that's the key point, is just because they're introduced to it because their boss says, hey, you must go do this, the key part is crafting an environment that's engaging and meets the need that they have. Otherwise, you're right back to, you might as well just give them a lecture with a PowerPoint and give the training we all hate of sitting in a classroom and receiving it passively because they don't want to be there. If you've designed your experience correctly, you're meeting a need that they have. You're providing them value. I do want to, because we're running short on time, I want to make sure that we get to all the comments we can. There is a comment from Claudine on YouTube. Can we generalize this so that educators are able to instantiate with any kind of subject matter?
Hey, Rotem.
Absolutely.
Can I take that one?
100. I was hoping you would.
So let's pop.
I think Dom already has slides up for you.
Yeah. So the good news is that yes, most subject matter is something that you can approach with this kind of gamification. The bad news is that different kinds of subject matter and different kinds of learning contexts need different kinds of support. So Dom, if you can, I'm still seeing the transfer of skills slide. If you can pop up to the CTP. So one of the things that is my mission here is go to the CTP slides, is thinking about how we take research and design for a specific kind of problem and approach them with gamification. So you can do, next slide, you can do good research, but if you're not actually doing good game design with it, right, that you may have an impact on people. It's sort of what we talked about, that it's not going to be fun, and you're not going to get the benefits of games, right? And at most, you'll have an experience that you call a game that you're forcing people to play. On the other hand, if you just make something fun that isn't grounded in sort of what we know about research, but is just a high quality game, then you're probably not going to get the transformational effects. But there's another piece, which is why we can't really generalize this, which is that we need to think about how we're deploying this. That when you're putting this, when you're having people learn, for example, I'm working with a group that's looking at physics and history. Those are two very different kinds of learning, both in terms of who learns them, when do they get learned, what kind of assessments and outcomes do people expect, how easy is it to measure computationally. And so if you're not sort of taking this context into account, then you end up with what we call deployment failures, right? That maybe you have a great game that in theory is making the kind of learning transformation that you want, or the kind of behavior transformation you want, but no one is willing to play it because you haven't thought about the way that it deploys in context. So I was really excited about the synergy here that as of 9 a.m. this morning, we have launched a center at Carnegie Mellon called the Center for Transformational Play, where our job is to work with people who want to, who have a problem they want to address with games and gamification. So, can an educator just do this on their own? Maybe, maybe not. But if you're an educator and you want to work on this, or if you want to be designing cybersecurity games, come talk to us. And we're already working with Rotem and Dom.
Yes, and so I wanted to highlight that we are deeply, SEI and the CTP are from their very birth very deeply integrated with one another. And so if you are in a government role, in a DoD role, anywhere in that space, and you need help, and you come to SEI to support you in that, we're going to be working with the Center for Transformational Play. We're going to be working together natively in order to ensure that we're bringing the best, the most cutting-edge research, the most skilled game designers. And CTP isn't just about game design. We're bringing in artists from the art school. We've brought in performers from the School of Drama before. We've done, we will reach out anywhere in the sphere where we can get the best talent available to create the most engaging, most motivating gameplay experiences that can affect that real transformational effect on your.
So we have about 2 minutes left, I think, in the presentation. I figure, why don't we jump over to measure and improve teamwork, or we wait for any final questions to come in?
Yeah, so games let us really build trust in a rapid manner. So if you have ad hoc teams that have to come together, execute on a mission, and then break apart, it's hard to get people to start talking, to have that willingness to share ideas, to feel that sense of flow, that they're engaged in their work. And especially for these short-term groupings that are fairly common in a developing environment, by the time you get that flow going together, you're already done. And so games can actually enable that. And we have a good body of research that we probably can't cover in 2 minutes about that. So I just want to highlight one of the examples of where we've used this for measurement, also for measuring teams. And so Dom, if you can play that video. So this is we had a quick turnaround, a mandate from an executive order where we had to assist DHS in creating an environment where we can identify, challenge, and reward the US government's best cybersecurity practitioners. And so we're looking at how do we actually get an entire team into an environment where we can really challenge the best of the best and figure out who's the most talented, the most capable. And so we created this immersive client where the teams would be confronted with challenges. In this case, winter superstorm hits a fictitious city, and all sorts of things go wrong. There's ransomware attacks happening while there's power outages, and they're trying to coordinate all of these activities, fix everything they can, and then we use their performance to determine who's the most capable team when a real crisis hits.
And we are just about at time, so maybe we'll just close by saying that, this is something that we would love to continue. These are the kinds of things that we would love to work on with you. Thanks so much for your questions all through this panel. It's been really great to have this be a conversation, and I hope that this can be to be continued.
Thanks, everybody. I would first like to say and echo what Jessica just said, and I really thank our audience for kind of interacting and providing the questions. Second, thanks to Jessica, Dom, and Rotem for having this conversation. It was great. It was nice to see how kind of gamification can really change the engagement and really kind of motivate kind of DoD and honestly everyone to kind of really stretch and learn beyond just kind of clicking through a pre-canned PowerPoint or kind of a HTTP web page animation. So thank you everyone for that. We're now going to head into a 15-minute break, and when we return, we're going to come back to chain games, powering autonomous threat hunting. And I will say it's a completely different type of games. We're talking about game theory at that point, but stay tuned. It's going to be really interesting, and hopefully we'll see you back here in 15 minutes, and keep the questions coming. Thanks, everybody.
Hi, I'm Phil Gross, a senior network defense analyst at the SEI. I'm the principal investigator of the SEI's Chain Games project for powering autonomous threat hunting. Threat hunting is a technique used by cybersecurity operations staff to find sophisticated attackers who have already evaded the network's initial defenses and are either already committing malicious acts or are preparing to. Threat hunting, however, is almost always done manually because human judgment is required to decide where, how, and how long to hunt. So it proceeds at human scale, while the network attack surface is already large and growing much faster. Despite threat hunters' best efforts, there are enormous volumes of data about numerous systems they never look at, and that's where attackers can hide. If we can find a way to conduct some level of threat hunting without requiring human investigators, we can cover much more of the network, forcing attackers to work harder to stay in our networks. So we've been researching ways to develop and evaluate autonomous threat hunting strategies using game theory, a mathematical tool for modeling decision-making among agents with different and often conflicting goals. In my presentation, I describe our team's work on chain games, a set of games that build on previous work in cyber deception and camouflage. Our chain games develop the concept of the attack graph or kill chain. A kill chain is already familiar to security professionals, but we treat it as an abstract space where attackers and defenders interact. I'll talk about how this process can not only produce automatable threat hunting strategies, but also make it possible to analyze and evaluate those strategies in an automated way, reproducing at a basic level the judgment process of the human threat hunter. If you're interested in learning more about these techniques and their potential, watch my Research Review 2022 presentation or reach out at info@sei.cmu.edu.
The effectiveness of this assurance by implementing a model, analyze, build practice based on MBE to catch problems early and throughout the life cycle of the system. However, to be successful, MBE approaches must use complex analysis that verify specific aspects of the system behavior, but shielding the designer from the complexities of the analysis. Examples of such behavior include control stability, timing, safety, and cybersecurity. Unfortunately, the analysis make complex assumptions about the design of the system. If such assumptions are not met, the results of the analysis are invalid. Moreover, assumptions from different analyses may even be incompatible with one another, compounding the complexity even further. In this project, we develop a novel approach to handle a collection of complex analysis applied to CPS MBE models and their implementations. In our approach, we first verify their analysis assumptions and assist the designer in the resolution of problems, and secondly, integrate their verification results in an automatic formal argumentation structure that proves how these results guarantee assurance claims that can be ultimately connected to the authority to operate.
Hello, I'm James Ivers. Software provides the core capabilities of most systems that we build today. To stay competitive, we have to evolve software quickly to face new challenges and use new technologies. But too often, the way our software is structured prevents us from quickly changing it to meet our evolving needs. Large-scale refactoring is a way to correct significant structural challenges, but it lacks dedicated tool support and takes months to years of development effort. Consequently, many organizations forego needed refactoring and accept the limitations of existing software. The SEI has created an automated refactoring assistant to dramatically reduce the time and cost of large-scale refactoring. It recommends refactorings that modularize software to solve key challenges and activities like breaking software monoliths into independent services or extracting strategic capabilities for reuse. Our research uses multi-objective genetic algorithms to search for solutions to these problems and generates actionable recommendations for software written in Java or C#. Check out our talk on refactoring for software isolation to learn more about how the refactoring assistant works and how it can work for you.
Welcome back, everyone. Hopefully, welcome you back from having seen the transformative gamification panel. And now it's my pleasure to introduce Phil Gross, who's going to talk to us about chain games, powering autonomous threat hunting. Phil came to the CERT division here at SEI in 2005 after working at several startups developing network sensing and incident response tools. At the SEI, Phil's worked on a number of different problems, pretty much related to cybersecurity and situational awareness, concerned with identifying and understanding security-relevant information in the large volumes of data that computer networks generate, which is especially problematic in government networks. In addition to his work on threat hunting, Phil has designed data visualization tools and advised on building data pipelines for collection and analysis of sensor data on large networks. And with that, let's pivot over to Phil's talk. Thanks, everybody.
Hi, I'm Phil Gross. I'm a senior network defense analyst in the Monitoring and Response Directorate of the CERT division of the Software Engineering Institute. And I'm going to talk to you a little bit about some research I've been doing into powering autonomous threat hunting using something I call chain games. This project that I'm discussing today grew out of conversations with people who staff cybersecurity operation centers, or SOCs. As everyone does more online with information systems that generate more data than ever before, and of course attracting more and more sophisticated attackers, it's no surprise that the people who staff security operation centers are very busy. As a researcher, one of my major interests is making automation possible in cybersecurity where it could make a big difference, and one of those areas in cyber is threat hunting. The SEI is currently in the early stages of research into autonomous threat hunting, modeled as games, so that the costs and benefits of decisions can be quantified, simulated, and evaluated. Hopefully, sometime in the later stages of this research in a fully automated way. We're not there yet, but we've defined a type of game that we think forms a solid foundation for this later research. I'm going to show you how that game works, then discuss what we plan to do in the coming year to relate that game to real networks and threat hunting scenarios, moving toward that goal of full autonomy. But first, what is cyber threat hunting? Why is it important? And why is it important to automate? Well, cyber threat hunting is not new. Clifford Stoll's book, The Cuckoo's Egg, was about a threat hunt he conducted in 1986. However, threat hunting as a formal practice in security operations centers is a relatively recent development as organizations start to appreciate how threat hunting complements to other common security activities, intrusion detection and incident response. Intrusion detection tries to keep attackers from getting into the network and initiating an attack. Meanwhile, incident response is the practice of mitigating damage, usually done by an attacker when the attack has culminated. Threat hunting addresses the gap in the attack lifecycle, when an attacker has evaded initial detection and is planning or in the initial stages of execution of their plan. These attackers are in a position to do significant damage, but that risk hasn't been fully realized yet. Threat hunting gives the defender another opportunity to find and neutralize attacks before that risk can materialize. The main drawback to threat hunting is how much time and expertise is required to conduct a threat hunt. Individual hunts can take days or weeks to run, meaning hunt staff have to make tough decisions about which data sets and systems to investigate and which to ignore. Every data set they don't cover is one that could contain evidence of compromise. A faster hunt can cover more data and introduce at least the possibility that the evidence, if it exists, gets noticed and brought to the defender's attention. At sufficient scale, hunt campaigns could be coordinated to cover more data or to more intensively cover interesting data sets. Finally, these faster hunts could serve as a scouting or reconnaissance process, giving human threat hunters information they can use to better direct their attention. To achieve the speed and economy of scale necessary to begin thinking about hunt in this way requires automation. In fact, we believe it requires autonomy, the ability for automated processes to predicate, conduct, and conclude a threat hunt without any human intervention. So that's the vision. A fully autonomous threat hunting capability that can investigate cybersecurity data at a scale approaching the one at which it's created. But we're a long way off from that goal. To start down this path, we needed to be able to model the problem in an abstract way that we, and someday in the future an automated hunt system, could analyze. We wanted to build an abstract framework in which we could rapidly prototype and test threat hunting strategies, possibly even programmatically using tools like machine learning. And we felt that a successful approach would reflect that threat hunting concerns agents who wish to hide in a network, and other agents who oppose them, want to find them, and evict them. This led us naturally to game theory as a foundation for the work. So we familiarized ourselves with some of the recent work in game theory, hoping we could find researchers already working in cybersecurity, ideally doing work that we could immediately adapt to our purposes. It turned out there was recent work we felt we could build on in this area, which dealt with one of the fundamental aspects of adversary behavior, the use of deception. Somewhat to our surprise, this body of work focuses on how defenders could use deception and not attackers. In 2018, for example, a category of games was developed called cyber deception games. These sought to investigate the effectiveness of deception in frustrating attacker reconnaissance. I'll point out that this work was contextualized in terms of the cyber kill chain, about which more later. And cyber deception games were zero-sum games, meaning that the utility of the attacker and the defender exactly balance out. In 2019, some additional work was published on cyber camouflage games, which were conceived of in similar ways, but were general sum, meaning attacker and defender utility aren't directly related and can vary independently. The goal of this work was still defensive deception, in this case in order to decide when to perform expensive deception tasks like OS fingerprinting more efficiently without losing effectiveness. It was really helpful to find this work, and seeing game theory applied to real cybersecurity problems gave us confidence that we could apply it to threat hunting. Deception was being analyzed as a defensive tool, but at least initially, we thought we might be able to take advantage of the analysis done in this work, but invert the logic. In the end, we decided a different approach was needed for our work. So while the work on cyber deception games mainly used references to the cyber kill chain to contextualize the work, it struck us as a powerful formalism that we could orient our model around. And now I'd like to describe to you what that model is, and walk you through some simple examples before talking about what we're doing now and what we plan to do in the near future. Our approach to modeling cyber threat hunting is a family of games we're currently calling chain games, because they're oriented around this very abstract model of kill chains that we just saw. We call this a state chain. Each state in a chain represents a position of advantage in a network, or in a computer, or in a cloud application, or a number of other different contexts in an enterprise information system infrastructure. You can think of an attacker initially establishing themselves in one state, say state 0. Perhaps someone clicked on a malicious link or an email attachment. The attacker's first order of business is to establish persistence on the machine they've infected so they don't get accidentally evicted. So they write a file to a disk and make sure it's executed when the machine starts up. By doing that, they've moved from initial infection to persistence, and they're advancing into state 1. Each additional step an attacker takes to further their goals advances them into another state. Now, it isn't free for an attacker to take these actions. For instance, if they're not a privileged user, maybe they can't set that file to execute, and trying will get them noticed by an endpoint security solution. So they'll need to try and elevate their privileges and become an admin user. But that's also suspicious. Both activities entail some risk, but they have a reward. To model this, there's a cost at any time an attacker wants to advance down the chain. But there's also a benefit, or a payout, that they achieve when they successfully move to a given state. The defender is not traveling along the chain like the attacker is. The defender is somewhere in the network, able to observe some of this, and sometimes able to stop the attacker from advancing. In the next few slides, we're going to talk about different rules we can make about how the attacker advances through the chain and how the defender may try to stop them. Fundamentally, all the games we're talking about here follow these rules. They're two-player games played between an attacker and a defender. The players and their actions will be color-coded to help you keep track. The games are all played currently over a fixed number of turns, usually 2 or 3 in these examples. Chain games are mostly general-sum games, so each player gains and loses utility independently. There are a few exceptions to this, which we'll see. Finally, we conceive of these games as simultaneous turn games. That just means that both players decide what to do at the same time, and those actions are resolved simultaneously. Before we leave this slide, I want to call 2 things to your attention. The first is that the middle chain here isn't really a chain, it's a graph. From the attacker's standpoint, this could represent a choice they make about exactly how to attack or exploit or otherwise operate within the network. Once that choice is made, we can think of the path the attacker chose as a chain. So even though the analysis is oriented around chains, there are ways we can treat more complex graphs to think of them like chains. The second thing I want to point out is that the payoff to enter a state, which you can see here on the edges of the second and third picture here, doesn't have to be the same for each state. We'll be using uniform value chains for the first few examples, but there's actually a lot more expressiveness in this cost assignment. For instance, in the chain at the bottom, S3 may represent a valuable source of information, but to access it, the attacker may have to take on some net risk. We'll talk more about this in our future work. The first game here is a very simple game, which we can call version 0. In version 0, the attacker and defender both have 2 actions each. The attacker can advance. meaning they can go from whatever state they're in to the next one, collecting the utility for entering the state and paying the cost to advance. In this case, the utility for each advance is 1, which is fully offset by the cost, which is also 1. However, the defender receives -1 utility whenever the attacker advances, so there's a zero-sum component. This isn't meant to incentivize the attacker to advance so much as it is to motivate the defender to exercise their detect action. A detect will stop an advance, meaning the attacker pays for the cost of the advance but doesn't change states and doesn't get any additional utility. But it does cost the defender 1 utility to detect, so receiving a penalty when the attacker advances gives the defender a reason to pay the cost for their detect action and avoid being punished for an attacker advance. Finally, both the attacker and defender can choose to wait. Waiting costs nothing and earns nothing. The table on the right is called the payoff matrix of the game. It shows what the total net utility for each player is when they play the game for a set number of turns, in this case 2 turns. Each row represents the defender choosing a single sequence of actions. In the first row, it shows what happens when the defender waits for 2 turns, across all the other different sequences of actions the attacker can take. Each cell is a pair of numbers that shows how well that works out for the defender, which is the left number, and the attacker on the right. This matrix shows every strategy that the attacker or the defender can employ in this game over 2 turns. Technically, it shows every pure strategy. You'll see a mixed strategy in a few slides, but for now, you can just think of these as all the possible strategies. So with that information, we can do other kinds of analysis, like identifying dominant strategies. And in this case, it turns out there's 1 dominant strategy each for the attacker and the defender. The attacker's dominant strategy is to always try to advance. That's understandable. The defender's dominant strategy is never detect. In other words, always wait. Intuitively, it seems that the -1 utility penalty that we're giving for an attacker to advance isn't enough to make it worthwhile for the defender to pay the cost to detect. So think of this version of the game as a teaching tool. A big part of making this approach work lies in choosing good values for these costs and payouts. In this version, we introduce some mechanics that let us think about when to deploy and detect attacker camouflage. You'll recall that the previous work on cyber camouflage games and cyber deception games modeled deception as defensive activities, but here it's a property of the attacker. This game is identical to version 0, with the exception that each player's primary action has been split in 2. Instead of a single advance action, the attacker has a noisy advance action and a camouflaged advance action. This reflects tendencies we see in actual cyber attacks. Some attackers try to remove evidence of their activity or choose methods that may be less reliable but also harder to detect, and others go boldly forward. In this game, that dynamic is represented by making a camouflaged advance cost more than a noisy advance, but it's harder to detect. On the defender side, the detect action is now a weak detect and a strong detect. A weak detect can only stop noisy advances. A strong detect can stop both types of attacker advances, but of course, it costs more. In the payout matrix, weak and strong detects are referred to as low and high detections. This, by the way, is the full payout matrix. I don't expect you to be able to read it, but I wanted to show it to give a sense of how quickly simple changes like additional actions can complicate analysis. Here's a detail of that previous payout matrix, showing all the defender strategies and 3 of the attacker strategies. It also shows that, despite the addition of a camouflaged action, the game still produces 1 dominant strategy each for both the attacker and the defender. Now, however, we've tuned the game so that the attacker should never advance. I'd love it if we could find a way to do that in real life, but unfortunately, like the previous game, this is an artifact of the way we've chosen to structure the costs and payouts. Incidentally, for those who may be unfamiliar with the term, a dominant strategy isn't one that always wins. In game theory, a strategy is dominant if it performs the best that you can expect to do, more or less, against a perfectly rational opponent. So while we're getting these particular strategies because of the way the game is tuned, we may find that attackers in real life play strategies other than the optimal rational strategy for some reason. And if they do, we may want to adjust our behavior to optimize for that situation. The most helpful tool for exploring situations in which one of the players is deviating from optimal play is simulation. We'll talk more about our current and future simulation work shortly. The last 2 games were played on chains with uniform advancement costs. When we vary that assumption, we start to get much more interesting results. As I said earlier, a 3-state chain like this is a very reasonable characterization of certain types of attack. An attacker gets a lot of utility out of an initial infection, sees a lot of value in taking a particular action on objectives, but getting into position to take that action may incur little, no, or even negative utility. Introducing chains with complex utilities yields much more complex strategies for both attackers and defenders. Here we see the output of Gambit, a game analysis tool, describing the dominant strategies for a game played over the chain shown below. The dominant strategies are now mixed strategies. A mixed strategy means there's no right strategy for any single playthrough. You can only define optimal play in terms of probabilities. For instance, the attacker here should always advance one turn and wait the other 2 turns. However, they should mix up when they make their advance, spreading them out equally among all 3 turns. This payout structure may reflect, for instance, the implementation of a mitigation of some sort in front of a valuable asset. The attacker is deterred from attacking the asset by the mitigation, but they're also getting some utility from making that first advance. If that utility were smaller, perhaps because the utility of compromising another part of the network were mitigated, perhaps it would be rational for the attacker to either try and advance all the way down the chain or never try to advance at all. Clearly more work is needed here to better understand what's going on, but we're encouraged by seeing this more complex behavior emerge from such a simple change. I'd like to turn now from the chain games that we've defined and toward our near and medium-term work. Most of this work concerns taking our abstractions and mapping them into more realistic environments. The first thing we can do is change the game itself to look more like an actual threat hunt. Threat hunting usually happens as a set of data queries, looking for data that shows evidence of compromise. We can reflect this in our game by introducing an information vector. The information vector changes when the attacker advances, but not all the information in the vector is automatically available to the defender, so some advances may be invisible to them. For instance, as the attacker advances from state 0 to state 1 here, there's no change in the information the defender has access to. However, advancing from state 1 to state 2 changes some of the defender visible data, enabling them to detect attacker activity. The addition of the information vector permits a number of interesting enhancements to our simple game. Deception can be modeled as multiple advance actions that differ in the parts of the information vector that they modify. Similarly, the defender's detect actions can collect evidence from different parts of the vector, or perhaps unlock parts of the vector to which the defender normally has no access. This behavior may reflect applying enhanced logging to processes or systems where compromise may be suspected, for instance. Finally, we can further defenders' actions by introducing actions to remediate attacker presence. For example, by suggesting a host be reinstalled or by ordering configuration changes to a resource that makes it difficult for the attacker to advance into. Another technique we plan to do more work with in the next year is simulation. As you've seen, small complications can result in many more options for player behavior, which means a larger space in which to conduct analysis. Simulation can give us approximate results to questions that are computationally infeasible to answer exhaustively. Another benefit to simulation, as we've discussed earlier, is that we can model situations where theoretical assumptions are violated and see if some theoretically suboptimal strategies have better performance in specific conditions. The screenshot to the right is the definition of version 0 of our game in OpenSpiel, a simulation framework from DeepMind. We've been getting familiar with it this year and plan to use it for more active experimentation in the coming year. Finally, as the last game example showed, we can use different advance costs on state chains to better reflect both patterns of protection in the network and patterns of attacker behavior, depending on how we choose to interpret the relationship of the state chain to the attacking player. More complexity here results in a much richer set of strategies than the uniform value chains do. There are other ways we can map primitives in our games to more aspects of the real-world threat hunting problem. We can use simulation to model empirically observed strategies, and we can map features in the information vector to information elements present in real-world systems. That's the heart of the work we plan to do in the coming year. I hope you found this talk entertaining and educational. I find this work very exciting. I hope you do too. And I look forward to any questions you may have. Thanks for your time.
Hi, everyone. And Phil, thanks for that great talk. We're now live here with Phil Gross and looking to kind of continue this conversation. Hopefully you guys can submit some interesting and challenging questions for Phil on either the Discord or YouTube. I'm going to kick it off with, so Phil, a lot of cyber attacks happen in seconds or even minutes. Would you would the approach you're talking to autonomous threat hunt be able to help with these kinds of attacks?
Yeah, I think that speaks to something that obviously I spent a lot of time in the work discussing where we are now, which is in a very early stage, and talking about the game itself. But I think it's pretty fair to want to think a little more about what the applications are and where this tool can be applied and where it can't. And there are attacks sort of that occur on lots of different sort of timescales, right? These very short attacks are probably some of the most common, right? So that, automated systems, someone clicks on a link and immediately stuff starts happening, and people want to get from that initial infection to some sort of effect on the adversary as fast as they can. And I think it's fair to wonder if threat hunting in an autonomous way could come in and maybe close that loop and get inside sort of, so to speak, the OODA loop of the automated attacker by responding with automation. I am not so certain that this work can apply in that way, although I'm not going to entirely rule it out, because I think that once you start automating a threat hunting process, I'm not going to say the threat hunting process, because I don't think you ever displace the human threat hunter. But if you start applying an autonomous threat hunting process ubiquitously in a long-term vision, it might be possible to get down into those timescales, but I don't think you're going to start there. But fortunately, I think there's a very interesting space to work in with the attackers that function along those longer timescales, because frequently the reason that these sorts of things are taking longer or that the timescale is extended as much as it is because there's essentially a multiple phase operation that's going on, where the adversary will gain an initial level of persistence and then maybe conduct multiple operations over time from one position, or maybe do surveillance and try and identify a time at which they can operate that is going to achieve maximum effect. And these sorts of adversaries are in a lot of ways, the most important adversaries and one of the most difficult adversaries to identify and to sort of mitigate and defend against. They're generally very targeted. This is the kind of activity and behavior you get into when you have a highly resourced attacker, when you have maybe a state actor or something like that. So obviously something that is of critical importance to the DoD and to other very high criticality sort of enterprises. And the sophistication that they need in order to get and stay persistent is speaks to it's an investment. It from a game theoretic standpoint, they're putting a lot of there's a lot of cost to that action. So they're going to want to receive a very high payout. For that reason, I think it makes a lot of sense, even if we're not operating on that really low, quick time scale, it makes a lot of sense to focus on these folks who are maybe doing their initial infection activity in a short time scale, but now they're going to be surveilling the environment. There might be some actual humans on keyboards. So now we've entered sort of a human time scale. And then eventually a long possible period of quiescent persistence, which indicates that they are trying to be judicious and careful about, and careful for them being very not careful for us, meaning that there might be a significant effect on us. But we can use that to our advantage by aggressively scanning our own networks with some autonomous threat hunting processes, and trying to identify those signs of compromise, and hopefully in terms that I'm using in my work, hopefully find them in the middle of the chain, or maybe even earlier in the chain, or at critical points in the chain as we start identifying and mapping these chains down into actual attack patterns, where they might not have already done any damage at all. They might have achieved persistence and been waiting for a moment, and now we can interrupt their attack activity because they're not expecting to be caught. So that's the idea.
I hope that answers the question.
It's actually a great answer that leads into a bunch of other questions, right? So there's an interplay between kind of your work and how to potentially cause obfuscation or signaling that forces the attacker to do new activities, which hopefully we have some other forms of detection on. So do you envision that there's some, to the extent that you're successful in that regard, maybe our other forms of defense pick them up and maybe we find them before the real. Is that part of the goal then?
I absolutely want to. One of the reasons that we were drawn to game theory as an approach is because we want to be able to evaluate the utility of the adversary's choices as well as our own, and be able to make them force them into double bind situations, right? So absolutely, we want to force them into behaviors that are going to be hopefully easier to detect, or we're going to force them to operate under uncertainty, whereas the defender frequently has to operate under uncertainty as to what sort of attack is going to be made against them. We want to make it difficult for them, even if they can attack a defender's activity, to sort of understand the motivation of that activity, so that they have to think, if now we have ubiquitous level of, maybe not incredibly sophisticated scanning, as I say in the presentation, we're not trying to replicate the level of sophistication that you're going to see in a human threat hunt, but even having a level of really sort of rudimentary algorithmic scanning that's going on at a much more intensive level than you have now will force their behavior to account for that. And if we can make that incorporate additional aspects of uncertainty, for instance, by using the same activity in the service of multiple different operations, such that they may be forced to, in an abstract standpoint, maybe the attacker has a choice of whether to cover up the evidence of their attack over here or leave it. And there are reasons, obviously, to cover up the attack, right? That's at a high level, we would call that a stealthy maneuver. But it might also be a stealthy maneuver to leave it. For instance, if they know that data is going to be observed before they can modify it and then copied off onto a system somewhere, then perhaps an investigator process has access to that information. So maybe a subsequent version of this game to model that might have additional bits in the information vector that describe the same piece of information observed from different vantages, to see if those two different vantages align with each other. Now, when I, as an investigator, perhaps I'm making a request of an individual machine on which an attacker is resident for a piece of information, and that piece of information is something that would have been modified as the attacker advanced through their attack chain. If they have modified that, but the original information was replicated off to another source, I could see that discrepancy and I can know there's something wrong. But if they leave it the same, and I'm proceeding from a different set of assumptions where I'm looking for pieces of information that look a certain way, right? Because I think that's evidence of attack, sort of a signature-based approach, right? Then they're wrong then too. So I think that's where I want to be in the long term, and where we want to be in terms of getting to the point where we have a game theoretic framework for conducting threat hunt, is being able to tune the parameters under which we operate, such that we can look at the different possible interpretations of our actions from an adversary perspective, and get it to the point where the utility that they have of taking one action versus another is no better one way or another, and ideally fairly small. But if we do that, then we give them almost no choice, right? So yes, I absolutely hope that we can get into get to that point.
And this is the first year of 2, right? Just to confirm. Yeah. Okay.
That's right.
Well, thank you so much, Phil. That's been great. Let me transition now. We have our next talk coming up, which is maturing assurance contracts in model-based engineering. It's going to be presented by Dr. Denise. He's a principal researcher and a technical director of the Assuring Cyber Physical Systems Directorate at the Software Engineering Institute. His expertise and focus of his research includes cyber physical systems, real-time systems, and model-based engineering and the security of cyber physical systems. In the real-time arena, he has recently focused on multi-core processors and mixed criticality scheduling. He's also co-authored and co-edited the book Cyber Physical Systems, where the authors discuss different application areas of cyber physical systems and the different foundational domains, including real-time scheduling, logical verification, and security. And with that, thanks.
Hello, I'm Dio Denise. I'm the principal investigator of the Maturing Assuring Contracts in Model-Based Engineering project. Today, I'm going to be talking to you about our first year's results. So our project aims at the challenge of the digital engineering that is basically called a model, analyze, build. And the idea here is to be able to create models first, analyze them for properties of interest, and once we are satisfied with them, build the system. And the reason for this is that the late discovery of design errors in DoD are very costly. For instance, when we introduce errors in early stages, and we discover them very early, let's say at the fielding stage, then the cost can raise up to 300x or more. So then for these, we use models. It is to use these models to be able to analyze them. And we use this analysis as a black box because there are complex analyses. But the challenges that we have with this analysis is that they make a lot of implicit assumptions. And when these assumptions are not met, then the results actually are useless, are invalid, right? So if these assumptions are kind of not met, we also have the problem that this complexity of the analysis kind of show up. Now the designer needs to get into the details of the analysis, try to find out what went wrong. And this is actually a barrier for adoption and kind of defeats the whole purpose of this black box analysis. So what can we do with this? So not only this is one of the problems, but also we have multiple claims. And for these multiple claims, we also have multiple analyses. For instance, we need to verify things about model checking, control stability, thermal dissipation, schedulability, and the like. And all of these have multiple analyses that need to be kind of combined together. But also, their assumptions need to be combined together. We need to verify that they are not conflicting with each other and that they are properly satisfied. So what we have done over the years is create a concept called analysis contract. And the analysis contract is a module that defines what is the analysis that we are trying to execute, what are the assumptions that we need to meet for this analysis to be correct, and what is the guarantee that we achieve with this, right? What is the property we verify? But these assumptions actually can be validated at different stages in the development. So for instance, some of them we can make very early determinations. We can very early define whether we meet the assumptions. And some of them we need to defer them until we have more data. And even we can get to the case where we need to verify that these assumptions are met at the code level once we have an implementation. And we need to enable all these with these analysis contracts. In the end, what we want to be able to do is to shift to the left and down to the implementation. What it means is we want early analysis. We want to enable this early analysis to evaluate these early design decisions, even with partial information. For instance, we can evaluate whether we can meet a latency analysis, an end-to-end latency analysis, even before we have periods. But at the same time, we want to enable this refinement. So as we add more information, we need to keep track of the pending information. We need to find out, once we have enough information, whether we can execute new verification procedures like schedulability. And in the end, as we have said before, we want to go all the way down to the implementation in terms of conformance. And for that, we will need to test different verification techniques to really make sure that whatever we prove in the model is also present in the implementation. So these analyses actually are used, and these contracts are used to create what we call an assurance contract argumentation, right? So in the end, a particular claim that we have at a high level can be supported by multiple analyses. And this analysis, the combination of this analysis will actually discharge the claim, but the complexity of the assumptions of the analysis sometimes can be high, and therefore it will require, for instance, a full analysis to be able to discharge a particular assumption. But at the same time, we can also have a very simple verification on data that we already have present in the model, or we need to defer the verification because we don't have enough data, but we have enough information to say there is no contradiction in the data that we already have. And this is what we call a proof of negation. Right? So in particular, if we go after just an example to say, imagine that we have a reliable auto brake that is able to sense with the radar and see whether there is a need to brake. We obviously will need to have a radar to brake at dead light. We need to brake before we crash, obviously. But we also need to have some fault resiliency, some cybersecurity, among other things that we need to add to this particular claim. And when we focus on the meter radar to brake deadline, then we need to have multiple verifications, such as whether the threats are periodic, and we may not have enough information to prove that right away, so we can defer that as a proof of negation, even verifying if there are any contradictions at the moment, whether the connections have been marked to be delayed, that we can verify directly in the data that we already have, or that the threats are schedulable. And for this, we will have multiple options to test whether the threats are schedulable. And the particular contract analysis that we will verify will create its own behavioral model of the scheduling to find out whether we can really discharge the claim that the threats are schedulable. In the end, when we talk about this contract argumentation in the development life cycle, the integrity of the analysis based on the verification of assumptions, we need to provide support to the designer. And this support is about verifying these assumptions in terms of, first, detecting whether there are violations or not, but secondly, and more importantly, suggest repairs. And if there are ways to repair the violations, we will suggest that. That's part of what we want to do in the infrastructure. But even sometimes we cannot really repair an assumption. So in that case, we can offer alternatives for different analyses that do not need to satisfy particular assumptions. Right? At the same time, when we refine the design and we need to verify where new data will enable new analysis, we really need to make sure that this new analysis will be properly discharged and go after the proof of negation that we also have, right? And one of the things that are important for us in this project is this argument reusability. So these analysis contracts allows us to have a self-contained module that we can reuse whenever we have different systems and we create different argumentations for claims. We can connect the modules to other analyses and create new argumentations. So if we talk about this integrity of analysis, how do we repair assumptions to prove a simple example? In this particular case, the harmonic schedulability bound analysis, we will have three particular assumptions: rate monotonic priorities, harmonic periods, and period equal to deadline. And we can start testing or verifying these assumptions based on the data that we have. In this case, the data that we have are periods. So we need to find out, in this particular case, whether the periods are harmonic. What it means is the periods are multiple of each other. And we can already see that period 2 is not a multiple of period 1. So we can suggest to say, we can make it harmonic if you want. If you can accept changing period 2, for instance, from 15 to 20, then we can verify this assumption and we can use this analysis. But of course, that may not be the case. And if that is not the case, we need to provide alternatives. So we will be able to create or kind of search for an alternative contract that will not have that requirement of harmonic periods that then the designer can use. Similarly, when we go through refinement, right, the presence or absence of data, in this particular case, the only data that we have is utilizations, will allow us to prove or disprove certain conditions, certain assumptions that we have. In this particular case, if we don't have enough data, we just create this proof obligation, as we have said in the past. For instance, that the utilization should be equal to the execution time over the period, but we don't have periods or execution time, so we mark this as proof obligation. Similarly, with the example that we discussed before with harmonic periods, is yet another proof obligation. And finally, period equal to deadlines. We don't have deadlines or periods, so therefore it becomes another proof obligation. But as we gather more data, for instance, when we get periods, now we are able to discharge the harmonic periods. And once we discharge that, we can continue reusing this analysis. And as we get more data, for instance, deadlines, now I can verify whether the periods are equal to the deadlines. And similarly, when we get the execution times, now we can test whether the utilization that we used in the past are equal to the execution time or the periods. So this is the way we keep discharging, testing the different assumptions as new data becomes available in the refinement process. Obviously, as we mentioned before, the concept of the contracts allows us to have different modularities, right? So these different modules, I will say, that we can combine. But we can also kind of preserve parts of this argumentation, parts of these combinations, and reuse the combinations by themselves. We can do this incrementally, as we were saying before, as new data becomes available. We can increase our arguments. We can increase, I will say, the kind of precision in the claims that we want to do. We can have different alternatives depending on the data that we have, depending on the assumptions that we can verify, different ways to discharge claims and assumptions. In the end, we implemented this in what we call a symbolic contract argumentation. We take advantage of the advances that had occurred in formal verification, in particular with constraint solvers, constraint satisfaction solvers. We use the C3 constraint satisfaction solver for SMT to encode the assumptions, the guarantees, and to be able to combine this argumentation and prove this argumentation or discharge the argumentation that we built for a particular system. This is implemented in an annex language, that is a sublanguage hosted in ADL, and it's a SARE tool. But we have a model query language that is adaptable for multiple languages, even though it works initially in ADL, it's also adaptable for SysMLv2 or any model that will have enough semantics to be able to reason about these constraints and contracts, right? And of course, this contract verification plan, that is how do we discharge the different claims, is part of the infrastructure that we are building. Of course, it's very critical for us to have this contract argumentation scalability. So we take advantage of the advances in different scientific domains. We exploit the efficiency of the algorithms that these domains have created. Sometimes they create greedy algorithms that are very fast, for instance, in real-time theory, that can be implemented in imperative language. We enable that. We assume that these algorithms are correct. In particular, they have been proven to be correct in multiple papers. But there are also some efforts to kind of formalize this correctness in some other theorem provers, like Koch in particular for real-time theory. And we also, for instance, assume initially the correctness of the implementation, leaving this verification, this conformance test for later on as part of efforts for code generation or deferred code verification. We expect to have a strong impact in certification because in the end, we are creating this infrastructure for an automatic and sound verification of assurance claims through models, which of course will impact the fielding speed. If this is adopted, that will actually allows us to do an incremental validation through the design refinement that we have. And of course, we want to impact the community of the digital engineering and ADL ecosystem to be able to support the DoD efforts in modeling and analysis, the architectural central integration practice that we have within the FDL projects, DARPA programs using ADL, and the like. In the end, we are creating basically a certification for the digital engineering era to support the model, analyze, build with automatic argumentation. We are strongly shifting to the left, starting very early to verify the design decisions, but supporting all this design through refinement all the way down to the implementation, and drive all these properties and assumptions down to this implementation in a scalable way that exploits the efficiency of analysis in different domains, but preserving soundness, meaning that we exploit the advanced informal verification to do this argumentation in a formal way that can actually preserve the correctness all the way down. This is our team. We are very happy to have a very strong team to support this effort. And we will be very happy to answer any questions, either in the question session or by email, using this email. Thank you very much.
Hey, thanks for that great talk, Dio. And right here we have Dr. Denise here with us. I want to kind of get right into it, but first I really want to ask audience members if there's anything you want to know about any of these topics, modeling, real-time systems, kind of the formal analysis, please post them into the YouTube questions or the Discord chat. We'd love to kind of hear from you. Pick Dio's brain, ask him anything about these topics. Truly, he's a wealth of knowledge on this stuff. So we'd be happy to kind of hear from you and kind of go there. I have a handful of questions here, Dio. So kind of first off, how do you know that you've captured kind of all the data you need to check the assumptions to kind of validate these models?
Yes, that's a great question, actually. So as you know, our approach is integrating these multiple analyses in this model. And this integration basically also captures the data that is needed. And as we mentioned in the talk, the data is captured in kind of two styles, if you will. One is what is needed to run the model and what is needed to verify the assumptions. So the assumption verification can be deferred. We say as soon as we do not have contradictions, then we're going to be fine. But then, of course, at some point in time, we need to make sure that those assumptions are verified and that data needs to be present to validate the assumptions. So we are also using the advances in constraint solving to really find out if we have specified all the data that is needed. It means that if we are not, if it's possible to find an assignment of values that will violate the constraints, and therefore it means that we are still missing data. So that is automatically checked by the approach that we have.
And so you're talking here kind of about, the model helps you kind of understand how much data and what to capture, and you capture that holistically. But can you verify the different analysis and the assumptions independently from each other? Or, does that, kind of having that data together, does it complicate matters?
Yeah, that's actually a very interesting observation, because typically the different scientific disciplines, different academic communities, if you will, develop their own techniques to do verification. And those techniques are based on their own abstractions. And as abstractions, they erase data. But the data that erased in one particular community, for instance, to verify timing, they will erase, for instance, value transformations. But if you want to, and that allows you to do a fast verification of whether you will meet the timing requirements. However, if you are trying to validate a value transformation, like in logical verification, then of course that is missing data, right? So then in logical verification, they will use this value transformation to really figure out whether the transformation is correct or not, but they will erase timing, right? So then at some point in time, we need to create this interface between the two abstractions and then verify them together to say, what if a certain bulk transformation is actually produced, but at the wrong time? So how do you kind of put them two together? And that's actually an interdomain bridge that we need to create. And that's kind of one of the objectives of our project, to go after that bridging, if you will.
Oh, interesting. I'm going to pick on a little, kind of one of your comments from a moment ago, one of your answers, which was, you talk about, kind of satisfiability analysis, and typically that is not kind of a fast process, right? It's a, kind of a big search problem. And historically, we kind of know this, right? A lot of formal models that take a really long time to execute. So help me understand, how do we scale this? How do we do it? Shortcuts tend to introduce errors. What are we doing about this?
Yeah, that's a good point. In what we are trying to go after here, there are kind of probably two line of thoughts here. One is where we can develop a single unifying model that will put all the domains, as we talk about, for instance, value transformation, timing, all of them together, and create a humongous model that will allow you to verify all the properties together. But the problem with that is that, of course, if it's tough to go after these, using these techniques for a single domain, putting them all together creates a nightmare from the scalability point of view. So what we are doing is actually a way to say we will reuse analysis algorithms that the specialized domains, timing, logic, control, have developed, but then we develop only the integration language. And that is where we use these formal techniques to say, during the integration language, where the description of the integration then is formal, so that we can really verify that they will work together, we will meet all the assumptions, but only at the integration level and not going beyond that, because otherwise it will not scale.
That's great. So I'm feeling there's a, almost a little bit of a trend here, right? So we talk about a couple of things about, kind of scalability, the tools to kind of help understand what data. A lot of this sounds kind of usability, and there's a kind of the barrier to entry historically on using formal methods. So can you comment a little bit? It feels like we're trying to head in that, make all of this a little more accessible, a little more usable for users. Can you kind of tell me, comment on that? Where are we headed in this?
Yeah, that's actually a very good point. There are plenty of problems to tackle. Let me just start with that, right? But in general, I will say what we are going after is we are trying to exploit what model-based software engineering and systems engineering is offering. That is to say, high-level models at the architectural level that will use analysis as a plugin to analyze particular properties. You can say timing, security, safety, all of that. Typically, they tend to be used and can be used as a black box. There's a black box where you have a description that is simple enough that you can run the analysis. But the problem is that black box actually is tricky, because if you make the model that doesn't match the assumptions of the algorithm, the analysis, then you will run into problems, right? So it's like, sure, let's take advantage of those analyses. There is some usability already in place, but we need to tackle the next step, that is, okay, if I get an error because something was not matching, then how do I correct it? And the whole machinery behind is what we are creating. And just perhaps to connect it to another thing is, sometimes with these complex models, we're trying to bring the best explanations of what went wrong and doing at a bulk level. But if we get deep enough to any particular analysis, say, value transformation to say, you make an assignment that will lead us to an incorrect value, then getting to that explanation will be tricky. So there is a lot of explainability research to be done, if you will, for those deep analyses that need to be tackled.
And so, I mean, that's a laudable goal to be able to bring these things, kind of to a wider audience, and the ability for DoD at large and really the kind of larger community that needs to build highly assured systems, even commercial air transport and other needs. And so correct me if I'm wrong here, but you're in the first year of kind of a 3-year, kind of journey here on this. What are we looking forward to? As we kind of progress. What do you see on kind of the next horizon?
Yeah, so the first year was actually to build up the core machinery of expressing these interfaces, this interaction between analysis, executing and finding out when they are wrong, what to do, what is the feedback that we can provide, do the trade-offs of some of them, or doing, I will say, variations and alternatives. The second year will be talking about, I will say, the interaction between the different domains as we described before. And the third year is about making sure that the implementation actually matches the model, the assumptions, and all that, right? So we're going all the way down to the implementation, as we said during the talk, and that's actually going for the third year. That's what will happen in the third year, if you will. And of course, during all this time, we will be doing experiments that are representative for the DoD and our customers.
And so, and I'm sure I know the answer to this one, right? But so, we're looking for partners to kind of go on the journey with us, right? I mean, so what's a great partner for you? I know that we have some in kind of say aviation kind of areas, but what are other options? What who can benefit?
Yeah, so the great question. Actually, anybody that needs these models that work inside physical systems, and of course the big push on digital engineering and model analysis build is actually at the core of our mission, right? So anybody working in that arena will really be a great partner for us.
That sounds great, and I hope there's some audience members out there that are kind of hearing that. It's a great way to get kind of really pro high-end expertise in formal modeling, and folks who can help you kind of develop your formal models. Really kind of make sure that kind of the software and systems you specify and acquire, et cetera, really are going to meet the up to the needs of kind of all the different properties that we can kind of check. We're heading into a break. We're going to return back at 2:15 Eastern time, and we'll be hearing a panel conversation, and it's addressing DevSecOps challenges. Dio, thanks so much for being here, and I really look forward to kind of hearing as we progress, and hopefully some DoD folks will be reaching out, and we can really kind of make an impact for their programs, especially kind of providing the kind of expertise that we kind of really have on this team. It's world class. Thank you.
Thank you.
Hi, my name's Tim Chick. I'm a Cert Systems Technical Manager and an adjunct faculty member at Carnegie Mellon University. Understanding and articulating cybersecurity risk is hard. With the adoption of DevSecOps tools and techniques and the increased coupling between the product being built and the tools used to build them, the attack surface of the product continues to grow by incorporating segments of the development environment. Thus, many enterprises are concerned that DevSecOps pipeline weaknesses may be abused to inject exploitable vulnerabilities into their products and services. An insurance case can be used to reason about the degree of security for both the pipeline and the product. The DevSecOps platform independent model can incorporate the elements needed to frame a software assurance case by showing how gathering evidence can be combined into an argument demonstrating that the risk associated with a given pipeline instance has been adequately addressed. This in turn provides the organization with the basis for making risk-based choices tied to assuring that the pipeline only functions as intended. Join me at my session to learn more about identifying threats and assuring your DevSecOps pipeline using model-based systems engineering.
Since 2004, the SEI has hosted Flocon, a conference focused on using data to defend networks. From its earliest days as a small gathering of analysts to discuss network flow, to its current focus on situational awareness beyond the network, Flocon has brought together researchers and practitioners to engage deeply with the latest tools, methods, and processes for using data to defend networked systems. This year's conference will be held from the 9th to the 12th of January in Santa Fe, New Mexico. Our keynote speakers are Rear Admiral William Chase, Deputy Commander of Joint Force Headquarters, Department of Defense Information Network, who will share his expertise and experience coordinating defense of diverse and volatile information systems, and Mr. Jay Gasley, Acting Associate Director for Vulnerability Management for the Cyber and Infrastructure Security Agency, whose experience with managing and coordinating security and vulnerability management for large-scale systems provides something for all of our attendees to learn. In addition to a slate of research presentations from the Department of Defense Cybercrime Center, Cisco, the Mayo Clinic, Chevron, and more, we are offering open source information security tools training and workshops on emerging web technologies and cloud deployment security. I hope you will join us in Santa Fe this January 9th to 12th, and I look forward to meeting you in person at Flocon 2023.
Hi, my name is Jerome Hugh, and I'm the PI of the Cypher project. The integration of artificial intelligence has significantly enhanced the capabilities of cyber-physical systems. Indeed, AI-based functions extend cyber-physical system capabilities by collecting and processing large data flows to provide advanced control, situational awareness, and autonomy capabilities. But at the same time, these advances make it harder to assure systems. Understanding the impact of AI functions on system safety is an ever-increasing challenge that requires a fine understanding of the system architecture. In the Cypher project, our SEI team of researchers is investigating the impact of AI functions on the assurance of safety-critical systems. So join us for our SEI Research review presentation. We will highlight how the SEI is advancing the safety analysis capabilities of AI-based cyber-physical systems. Our work considers model-based engineering and architectural modeling as key enablers for system assurance. We expand model-based system engineering with mathematically grounded techniques to analyze the architecture of AI-based cyber-physical systems and derive an argument on their safety. So join us to learn more about the Cypher projects and its contributions to improving system assurance.
As your organization adopts a software pathway to facilitate rapid and iterative delivery of capability, co-evolving architecture and code becomes increasingly important. One of the reasons that you invest in architecture is to ensure your system is extensible to provide for affordable future growth. Unfortunately, developers sometimes implement code that diverges from that architecture and puts extensibility at risk. Many times, these discrepancies are only discovered much later, when you're building a future release. At this point, remediation is more expensive and will likely delay delivery of new features. I'm Dr. Robert Nord, Principal Researcher on Automated Design Conformance during Continuous Integration, a project that developed a prototype tool that automatically checks that each code commit conforms to its intended architecture. The key to this work is new research in extracting design information from source code, a challenging task because there are few indications of intent in the code and because implementation shows significant variations. We exploited the use of software frameworks to advance automation and architecture analysis. Have a look at our presentation to see what conformance checking is feasible today and how continuous integration can be extended to improve the conformance of your implementations to your intended architectures.
Welcome back, everyone. I hope you got a quick break and something to drink. We're going to continue on with Tim Chick. He's going to deliver a talk on addressing DevSecOps challenges. It's a short video, and we're going to follow that up with a panel that's going to talk about the cybersecurity challenges associated with DevSecOps. Tim Chick currently leads the software and systems engineering team, focused on delivering trusted, valued, and relevant software engineering and cybersecurity approaches for software-intensive systems. It does a lot of work both in the Department of Defense as well as Department of Homeland Security. He's also an adjunct faculty member at CMU's Software and Societal Systems Department. And with that, I'm going to pass off to the quick intro, and then we'll head into the panel. Thanks, everyone.
Hi, my name is Tim Chick. I am a CERT Systems Technical Manager. I'm also an adjunct faculty for the Institute of Software Research. I'm here to talk about addressing DevSecOps challenges using model-based systems engineering. So kind of the agenda, I'm talking about what is DevSecOps, what does it mean to me, and then talk about these basic two challenges, connecting the process, practices, and tools, and then also the cybersecurity aspects of DevSecOps. And then finally, how you can start addressing these issues with model-based systems engineering. So DevSecOps, what is it, right? So here's a definition of DevSecOps. The key here is it's a cultural and engineering practice that breaks down barriers and opens collaboration between development, security, and operations, right? A pipeline is really the connection of what some could describe as factions or traditional factions in a traditional waterfall software development organization, right? You have development, which values features. You have security, which values defensibility, and you have operations, which values stability, right? If you really think about that, the operations folks, they're being measured by uptime. How long is the system available? How long is it, is it reliable, right? Where developers are always focused on the next feature, the next capability. And then you have security as how do I defend it? How do I make sure that only the right people have access to it, right? And when you have that, and you look at the diagram here, right, what you see is you have these factions trying to work together, not always agreeing, right? But then they're being squeezed by this risk, the benefits, the quality, the business aspects, as well as time, scope, and cost, right? And they're just constantly pushing on, and that actually creates more friction between the organizations. So then you also need to take an enterprise view, right? A lot of people, when they talk about DevSecOps, they focus on the product, right? That's just one section of it, right? That's that value that you're developing to a customer, or that service that you're providing, right? The other two aspects of it is the vision, the business mission itself, right? The why and the who the enterprise exists for. And then also this thing called the capability delivery, right? This is actually the people, the process, the technology that enable the organization to build and produce their products and services. And at the bottom, you have this common shared infrastructure that supports the entire enterprise. So what are the challenges? So the first one is this interconnection between process, practices, and tools, right? DevSecOps is not a static thing. You don't set it up and then you just walk away, right? The tools are constantly changing. The products and services that you're producing, they're evolving, and with it, the capabilities that enable those products and services need to evolve. Sometimes your business mission changes. Maybe your user base, what they want from you, your customer base change, right? So these things are constantly changing, and that impacts your ability to produce, right, and build and operate effectively and efficiently. The other part of that is a lot of organizations say, hey, I'm doing Agile, I'm doing DevSecOps. Problem with that is well, how are you doing that, right? George Box, famous mathematician, is quoted as saying, all models are wrong, but some are useful, right? While he was talking about mathematics, it's true for most Agile and DevSecOps techniques and methods as well, right? They were developed and they were designed to meet a specific need, right? They have their ideal, team size, their ideal technology set, their ideal architectural view, right? And so the key is am I to pick the right methodology that meets my specific need, right? And this is why it's really hard for one to say that I'm doing Agile, or I'm doing DevSec, correctly, or if I'm not, right? So I really, so what do I do, right? Well, there's three kind of fundamental factors, right? The ability of the organization, right? It's change, right? Change management takes time, it takes resources. And so do I have those things available to adopt this new methodology or this new technology, right? The other part is determining the suitability of the advertising practice in the development of the given product or service, right? Certain techniques are good at certain things, right? And so make sure you have the right environment for that, right? And then the sustainability of the advertising practices in organizations, right? How do I maintain this? How can I, continue to support it? The second challenge is cybersecurity, right? I took this view and I put this web over top of it, right? The idea here is that, traditional cybersecurity threat assessments, threat analysis really focus on just the product here, right? But with modern software development and modern software engineering techniques and tools and practices, the pipeline and the product have become so tightly coupled, right, that it is possible to attack the product through the pipeline, right? And so the attack vectors have really just grown almost exponentially, right? And so how do I secure that? How do I do the analysis? How do I determine that I've done a good enough job to address the attack surface, the threat of some type of cyber vulnerability taking advantage of my system, right? So, to address that cyber issue, right, you got to think about, well, what's a term called software assurance. Software assurance is really the software engineering aspect of cybersecurity, right? It looks at, the level of confidence that software is free from vulnerabilities. And the second definition, which I actually like better because it starts with the positive, right? It's application of technologies and processes to achieve a required level of confidence that software systems and services function as intended, right? Or in the intended manner, right? And then it's free of accidental, right? And it keeps going on. The reason I like this one better is because it starts with the assertion, right? And then from an assurance case, and we'll talk about that in a second, the rest of that definition are defeaters to my assurance, right? My level of confidence is only as good as the way in which I have addressed those things that would defeat my ability to defend my system, right? So again, so how I determine that is really a few factors. One is risk. The perception of risk drives assurance decisions, right? The other aspect is the integration, right? Highly connected systems require alignment of risk across all stakeholders and the system, right? Go back to the original diagram, right? You have the product, the capability, and the enterprise. All of those stakeholders are in play. All those stakeholders impact your ability to secure your system, right? And then you have to trusted dependencies, right? Your assurance depends on other people's decisions and the level of trust you place in these dependencies, right? There's lots of players in your organization, different tools, different techniques, tightly integrated, tightly coupled in a DevSecOps pipeline, right? And then you have the attacker, right? And the key here is there is no perfect protection against attacks, right? This idea that you can reach this 100% security where no one could possibly do anything bad with your system, it's not just it's not an economically achievable thing. So how do I mitigate that, right? You understand, first thing is understanding risk is hard, right? And so what I need is the ability to quantify or reason around the cybersecurity risk associated with my product and my DevSecOps pipeline, right? Without that, I'm not able to properly balance between features, defensibility, and stability, right? Go back to that triad at the beginning of the definition of DevSecOps, right? And I also need to make those trade-off choices to achieve my organization's mission within a cost-effective way, right? I only have so many resources that I can apply to security. So I also need to build features, and I also need to operate the system, right? And so an assurance case is a way of doing that, right? It allows you to reason through it. Using assurance cases in software isn't new. Safety-critical software uses those techniques. And we also believe that it can very much apply to cybersecurity as well and help to address these issues. So what is an assurance case, right? It's really a structured reasoning system, right? You start with the claim, and I go back to that software assurance definition that I provided, right? It's, I only function as intended. So in this case, it's a DevSecOps pipeline, right? I only function as intended, right? And then I have subclaims, right? And make arguments to show, and then evidence, right? To support my claims, right? And having a structured way of doing that is really where model-based system engineering comes in. So addressing the model-based system engineering, right? So how's it done today, right? Well, in the Department of Defense, right, a couple of guidelines there. What they really do is they say, I want you to do DevSecOps, I want you to do process improvement, but it's really up to the program office to make the final decision, right? Program office shall ensure that software teams use iterative and incremental software development methodologies, right? And use modern technologies, right? So it says to do it, but there's a complete lack of sufficient capabilities to design, build, and implement a DevSecOps pipeline consistently, right? Current guidance fails to prepare programs to address the socio-technical aspects of DevSecOps, right? It does not define it. It does not provide a definitive reference of source that one can use to actually evaluate different alternatives to solving or building your pipeline. So that really brings me into this platform independent model concept, right? So, it's built off this reference architecture construct, right? Reference architecture is authoritative source of information. A PIM is really a general and reusable model for solutions. And for our place, we created DevSecOps platform independent model. And really where it fits in is if you just go out and do an internet search for DevSecOps, you usually find two things. One being a high level, usually the infinity diagram, academic kind of description of what DevSecOps is and some basic principles around it. On the other hand, what you will find is, buy my tool, buy my solution, right? Someone's, a vendor trying to sell something, right? Well, how do I, from an engineering perspective, rationalize which tools I should use, which processes I should use, right? I really need that next level of abstraction and detail beyond the academic piece to allow me to be a good consumer and actually apply engineering to build my pipeline using the right tools and the right techniques that are available from various vendors, or I could build my own if necessary, right? So that DevSecOps platform independent, right? The idea here is that it's an authoritative reference to fully design and execute an integrated, agile, and DevSecOps strategy, right? Which really involves all the stakeholders, right? A lot of the material out there also really focuses on the software developers' view of the world, right? We also need to worry about the security's view of the world and the operations aspect of the world, right? It enables an organization to really think through and do analysis of alternatives for, pulling the pieces together and be really conscious and thought in terms of building their pipelines. A lot of organizations we go out and we work with, we ask them, well, how did you make that decision? Well, we just kind of picked it, right? And well, why is it not working for you? Well, we didn't know we wanted to do X, Y, and Z, right? Software engineering, system engineering, model-based system engineering allows you to think through, I want to do X, Y, and Z. Now I have a criteria to figure out which is the right tools, which are the right techniques to really increase my ability to be successful, right? So what does the models consist of, right? So we used UAF, Unified Architecture Framework. And so the DevSecOps PIM consists of basically 5 main categories, right? One is being the requirements, right? Focuses on, thou shall statements. What are the different aspects one would want to build this pipeline? The other is the capability and the strategy views, right? So if I understand my requirements, what are the basic capabilities that I need to fulfill those requirements, right? And we came up with 10 of them. The next part is its operational views. What's the process? What are the interconnections between the product and the capability? How do they come together? And how do they intertwine with the business aspects? The other part is personnel, right? While we're platform independent, we don't say, this person does this job. There are some critical roles within the DevSecOps pipeline. This is just a snapshot of some examples, right? You got the business aspect, you got the engineering aspect, you got the operational aspects as well. And then, you need to bring them together, right? The intersection between these different aspects is really a key aspect, right? What roles map to which activities, and what is their role? Are they performing the activity? Are they observing the activity, right? Are they approving the activity, right? Those aspects also come into play because that is usually where issues fall, is the interconnection between these techniques. Another example, operational activity matrix, again, bringing the connections together, right? And the other part is threats, right? What are the threats to my pipeline? What are the areas of concern, right? Based on the technology, based on the requirements, based on the interconnections, right? Model-based system engineering has the ability to capture those effectively, and then what you would expect is in a platform-specific solution, they would explain how they address that threat, how they mitigated that threat, right? And that goes back to your assurance case of, I've mitigated this defeater sufficiently that I can move on, that I'm assured that my pipeline only functions as intended, that my pipeline is not going to infect my product or impact my customers. Right? And here's kind of an example of bringing it all together, right? The very center box is hard to see, is the single activity. There's larger boxes are the threats, right? And then you have the attack aspects, as well as the yellow oranges boxes, where are the players, right? You have the attacker, you have the roles and responsibilities of the people who are responsible for mitigating that particular risk, right? Model-based system gives you the ability to actually capture all those constructs and see their interconnections, and then begin rationalizing how one could mitigate or how one could address that threat, right? And then another example of the views showing how all these things can come together. You begin actually applying software system engineering concepts to do the analysis to really build the assurance case that your system only functions as intended. So DevSecOps really enables organizations, projects, and teams and acquirers, right, to really specify what DevSecOps is, what they need, what they want. This is especially needed when you are hiring someone to help you build your pipeline, or where it's not really the main focus of your business, right? It allows you to really do analysis of alternatives to say, okay, which features do I want? How does changing this particular feature impact my organization before I implement it, right? And it provides the basis for threat and attack surface analysis. And it can help you build that assurance case to really understand that my system only does what's intended. And I've mitigated adequately the unintended side effects. So kind of in summary, right, with model-based systems engineering and the DevSecOps platform independent model, you begin doing the right analysis to understand and build that socio-technical system that is trustworthy, predictable, and timely. So this is our team that really helped enable and build this platform independent model for DevSecOps. We're very much looking for collaboration, so please feel free to reach out to us, info@sei.cmu.edu. Thank you for your time.
Hi, everyone. I hope you enjoyed the video as much as I did. I want to remind you this is a live panel, and we're really looking for your kind of questions and interactivity here, and the topic cybersecurity challenges associated with DevSecOps. And I'm going to introduce you to our panelists. We have Miss Natasha Shavenko. She's a member of the technical staff here. She specializes in system engineering and model-based system engineering and threat modeling methods. I've already kind of mentioned Tim Chick. We have Joe Yankel. He's a senior engineer and initiative lead for the DevSecOps innovation at SEI. He's focused on analyzing and improving the DevSecOps posture of organizations working with us. And Dr. Carol Woody, who's an experienced researcher focusing on organizations to identify effective security risk management solutions and developing approaches to improve their ability to identify security and survivability requirements. And with that, I'm going to hand back off to Tim. Go ahead.
All right. Thank you, Chris. So I just want to start off with a few questions. The first one, Carol, let's start with you. Why is assuring the pipeline so hard?
So you're dealing with third-party software and hardware and services, and they're major factors for both the pipeline infrastructure and the developing product. It's complex enough just to assemble all this stuff, get it operating, or get the product working, much less worrying about the cybersecurity risk for all this range and the capabilities, and it can be very daunting. We've got to deal with a mix of software at multiple levels. Each one of the products that you've got or components, especially if you're dealing with a lot of third party, have different unique outputs, limits, logging capabilities, error handling. So all this information has to be accumulated and monitored and managed somehow. And these tools weren't designed to work together. So when we're building a flow, you're actually creating scripts so the pieces will work together. That's more processes. And as you automate all of these pieces over time, you're creating a situation where it's more and more difficult to actually see anomalies. You're removing the human in the loop, and you have to actually create ways to monitor and manage the parts and pieces that are moving, so that you can identify potential risks and react and adjust to them. Plus, all this software has to be updated over time too. It's a lot of things to get done.
Oh, okay. Natasha, do you have anything to add? Or Joe?
Yeah, I think I can add a couple words to that. Is on the point that we are removing the human from the processes. We're removing people from a processes that immediately involved with the process, like do process the information, do the work by themselves, but we still have them, or even have the humans on people on as a different role. They have to configure all of the tools, and this is another surface of potential attack, because you have human that actually can configure a tool that do something wrong. So it's not like we're removing the humans completely from. We change their role in a system, and sometimes it's even make the whole process more complicated, because it's not obvious that humans is there. Human in some way is on a big stage, actually coordinating and coordinating the processes and organize them as pipelines. So this is additional complexity, add additional complexity to the system, and some of this complexity is not obvious complexity.
Right. So I think there's actually a good transition between the complexity that Carol talks about and the human factors you're talking about, into kind of our next question is, why do we need, a model to support the software assurance of a pipeline, right? And, and my kind of take on that is that, while there are techniques out there for building assurance cases from the safety assurance aspects practices, these are all really guided by the laws of physics, right? And trying to apply some of those same techniques to assuring a system, right? Cyber assurance. You really start needing that model to bring that structure to be able to create some standardized approaches and really think through the assurance of the threats and how they impact and how they work through and how do you mitigate those things, because ultimately you're trying to assure that the product in the pipeline only do what they're intended to do and nothing else, right? The concept that I can assure that the system is 100% secure is really a false assurance, right? You can't really, the adversaries are constantly coming up with new techniques and new ways to try to circumvent your security measures. So really you're trying to determine the resiliency of your system and then ensuring that it does what it needs to do. And so I think a model helps provide that structure, that system engineering approach to it. Do any of you have any other thoughts on that?
I would add to that the model helps you organize all of these many pieces of details so that you can actually flow pieces together. You can reassemble them with different views in the model so that you can put together multiple perspectives and compare them to each other. and actually create pictures that you can bring multiple people together to analyze, so that you can put shared eyes on the problem as well. I think all of those add value.
So Joe, what are your thoughts? This whole model-based system engineering and DevSecOps, bringing them together was kind of new with this research. What was your take on that and the lessons you've learned through this research?
You know, a little bit the same as what everyone said. It's really hard, right? So some of what we've been asked to do, model-based system engineering, digital engineering, DevSecOps, it turns out it's very complex. And what we discovered is there's a lot of guidance out there. But as you dig in deep, a single source of truth, right? A formal method for doing this we found it to be very valuable, right? To understand details about these processes, especially about the people involved, right? So helping organizations understand the roles necessary to do this was it's something a model's strong in, right? It's a really good, solid source of truth for all the different expertise. So that's what I'm seeing now is that it's a great way to collaborate among other experts at our own institute, bodies of knowledge that we can capture in the model as far as these being really good practices and processes that we should follow.
One other thing I think the model helps with is to project. You can do planning. You can play what if games with it. What if I change this? What's it going to change? And that's hard to do outside of that.
So Natasha, do you have something to add to that question, or you want to move to the next question?
I just wanted to add one comment. I absolutely agree with Carol that model facilitate these games, what if, and especially it's easier to work with what if scenarios if you have a common picture in front of several people that can present their separate points of view, and that in the end you will have a solution, you will have a decision that would be better if these people will think about it on their own. And actually model itself, like PIM, gives you this picture in the middle of a table that everybody is around and thinking about it, about the same picture. There is a language that shows you, helps you to facilitate this thinking and present this information in a common way for everybody. So I think Carol's point is very important.
So that kind of leads to difference. I mean, you mentioned modeling. What's the difference between a platform independent model, platform specific model, and how do those contexts really help with threat identification?
Threat identification, threat modeling actually start with collecting information. The data flows, you need to identify the assets, you need to identify the actors that participate in the system, in their roles, their involvement, or you need to identify threat boundaries. There's a steps that almost any threat modeling methods employ, but and PIM actually gives you all of this information. It's already there. If you have the model, it's a PIM that you use as a reference architecture, or you created a platform-specific model for your system, you already have a data flows there, you have a data structure that needed for threat modeling. You have potential actors, external, internal, that involve in these processes, or actually have access to your assets. And essentially assets, it's part of your architecture, or it's critical processes that your business need to implement. And they can be asset by themselves, or pieces of information then flow between them. So it's almost there, and you can, if you use for example, PIM, you already have kind of set of threat scenarios and threats that related to the spam on a high level. So you can look at that and see how it's related to your specific system. Is it enough already for you to analyze your system and identify the threat that's specific for you? And PIM contains a list of types of attack developed by Matter. So we provide it in a PIM where you can use for your threat modeling processes if you want to. So it's in some way for threat modeling, it's one-stop deal. If you have your PIM or like PSM, platform-specific system for your system, you have already everything needed to start your threat modeling and threat identification.
Yeah, so I mean, what I see is, and kind of the lead on to that is having that platform-specific model, or the platform-independent model, excuse me, really provides that reference architecture that allows really large organizations who might have multiple pipelines supporting multiple customers, multiple capabilities, multiple value-add propositions, to really have some structured approach to bring consistency across their enterprise for starting to build those assurance cases, to do their threat identification workshops, their vulnerability discussions, as well as their mitigations, right? Because you have, when you build an assurance case, I want to prove that it functions only as intended, and really those threats and those cyber concerns really become defeaters to my assurance case, right? And so the PIM provides the structure to be able to build a consistent assurance case argument. And then your platform independent model, when you map it to that reference architecture, provides the evidence one needs to make those claims in your assurance case. And I think that's really key, and how they kind of can work together to really complement that threat identification, but then that follow-on threat mitigation. Joe, do you have anything else? Any other thoughts on that?
I think, like you said, it's a great one-stop shop, as Natasha said, to capture all these things. It really is. It's difficult, right? As we really try to plan assurance, we realize it's planning. There's hardly a better planning tool than a platform independent model to plan what you do, right? You have a chance then, if you understand the scope of what you have to assure, to possibly achieve that. We've seen a lot of organizations, right, fail to close the deal, so to speak, right? Begin to build this environment up without having done that planning, and they fall short.
Well, it forces
I
you
think
to
that PIM is great.
Well, it forces you to take into account a range of expectations that you might not have immediately come up with, because basically you've got a baseline to work from. And if you're just assembling tools and putting together your own pipeline and not really looking at what is a standard base of consideration, you're going to miss things.
Yeah, so I think that planning and that consistency, right, that's really key, right? If you don't have that complete list of items, you can't really have a complete plan. And I think that's kind of, Joe, what you're talking about, is we've seen people go down this path of building this capability, building these pipelines, but they didn't think it through. They didn't really understand how difficult it was and how all the elements needed to interplay with each other to be successful, right? And they've suffered because of that, through technical debt, through a lot of rework, a lot of missteps. Having that PIM, having that holistic view, how things work together, you can begin thinking about and mapping out, what is my implementation plan? How am I going to build my model? How is it all going to work together? And that's really key, just from a basic, project planning, project tracking, and building, a good capability for your organization. Little learn the cybersecurity implications that now I can also make sure it's defensible, and I'm using good cyber hygiene. Especially in a world where finding people who have these skills, who have the experience in DevSecOps, sufficient to build something from scratch is really hard to find. Having that reference architecture, having that model with that information there, that checklist, so that people who are more novel at it, have that guidance of those experiences. I think, Joe, you kind of mentioned, it's also a great way of bringing lots of different experts together, capturing that tacit knowledge that's in between their ears and helping make it a little bit more explicit for the rest of the world to benefit from, right? So Joe, I got one last question. We'll see how it goes. Maybe we'll get a few more in chat. How do you envision the model being used in the future?
So this is what I'm excited about, right? We've really just started down this path of right now. We've captured a lot of SEI expertise, right? In the past, what we found is different experts approach something in their own way. It wasn't very repeatable. One of our objectives is to teach others how to do this, and so a model provides that platform. So going down that line, right now we do lots of DevSecOps assessments, right? Let's go look at an organization. Let's see how they're doing things. And often what it looks like is we have a particular expert that asks questions based off of their own expertise. And it looks different every time someone does it. A different person does an assessment, might get a different result. So one way we're going to use the model is to be a foundation for describing the activities, the people, the things that happen to do good DevSecOps, right? We have requirements, we have capabilities. That now is a very consistent platform to assess the current state, right? So step one, we're learning how to improve the model from the viewpoint of an organization self-assessing where they are to understand, here's what I do well at, here's things I can improve upon. It's really strong in saying, these are the organizational people I need, the personnel I need to do these tasks. That's often very enlightening when we find out there's a lot of work here. Are we sure we want this person doing this much work? It really allows us to see that it takes an army to potentially build software with DevSecOps methodologies. So when we can catch that very early, we can plan to hire those folks early. So that's one place we see it. I'm sure some others can add some other ways we're already using it today.
Well, I'm particularly enthused about creating a place that's organizing cybersecurity requirements for a pipeline. Too frequently, a laundry list of all of the controls and what needs to be done is provided as the acquisition requirement. And then you try and figure out what does that mean for a pipeline, because you're dealing with a different way of structuring product construction. And you also have to be looking at it from multiple perspectives. And the requirements allow you to start to divide up and assign responsibilities. So I think all of those are good starting points for not only creating a pipeline, but evaluating ones that are already existing to say, where are the gaps? How can we improve? How can we move ahead so that we are creating a better, more efficient environment at the same time, creating a better result?
Natasha, where do you see the model going? Do you have any thoughts?
Yes, I would like to see that PEM will mature as a tool, a little bit more tool of MBC for DevSecOps. I would say that one of the probably innovation with this tool is that we approach DevSecOps as a system, from system engineering point of view, not pipeline, not just tools. And it's mean that we can now apply system engineering methods to analyze the DevSecOps as a system, use gap analysis, use impact analysis, and so on and so forth. So PEM can provide these tools right there. So we can add some analytical views that will help organizations not only implement their pipelines, to do decisions consciously. If they decide that something they should not do, or they need to go to different level of maturity, they will have a tools to make this decision after careful analysis of all information they needed for that. So tool can provide this, PIM can provide these tools. This is one way I can see PIM goes. Another is to provide organization guidance how to create platform-specific models for themselves, because it's not trivial. So you right now it's numbers of reference architecture everywhere that actually talk in specific tools, platform specific tools. But we will try to create a transition. I won't say that stress-free, but at least it will be easier transition from PIM to PSM, so the organizations can create models for themselves, create specific architecture for themselves, and have the tools, again, system engineering tools right there to do conscious decisions, not just looking what is fancy tool right now out there, or what is like fashionable to do it right now, right? So this is a couple of areas that I think the PIM can be developed and be more helpful to industry and to any organization that want to do the DevSecOps a little bit more structured and formal way.
Okay, so I do have a couple ideas too that I don't think any of you really brought up or touched. And one is the idea of DevSecOps measurements, right? I think that's really a key weakness in terms of the DevSecOps practices and the research out there. And so how do you really articulate, where those right decision points are within the various aspects of your pipeline, and then what data can help inform those types of decisions, and really think that through from a real holistic view of, based on the roles and responsibilities, what questions should you be asking? What type of data throughout the pipeline can answer those questions from like a goal-driven measurement construct, as well as, through the automation and through the tools, what data can be collected and correlated across your different, types of tools and data collection aspects to actually begin quantifying, answering those questions, right? I think that's, a great place that the model can go to help support. And then secondary to that would be, with that additional data, how do I begin to describe residual risk, right? I think that's another area that cybersecurity as a whole struggles, even not just DevSecOps pipeline, but just in general, is how do I move from this compliance checklist type of cybersecurity approach to really being able to articulate and defend my decisions on what controls I included, or even more importantly, what controls I didn't include and why I did that, and really be able to quantify and not just, gut feeling, some basic arguments to really build, a quantitative assurance case around being a defensible system. So I think that's another area that the model can lead. And then I think even further going forward is really thinking machine learning operations, right? I think there's a lot of automation there. How do I trust that, when I put, artificial intelligence and machine learning constructs into my pipeline, where does that fit in? What does that look like, right? So I think those are a few additional areas I think the model can go towards into supporting that. We do have a question here. I think we have like 2 more minutes left. What level of maturity is practical to achieve today? Any thoughts on that? Maybe Joe, you do a lot of assessments. What do you think about that level of maturity construct?
I mean, we see various levels of maturity, right? Folks can develop software today and systems that they're not all the latest best practices. I think we understand what the future can hold, and we think that's a very mature system. Eventually, that's what we strive for, right? We strive for high mature systems where we have automation and AI to help us make intelligent choices. And so we'll see. We'll be happy just if most organizations right now can be level 1. We can develop software and we can describe what we've done and how we've secured it and how it has high quality, right? To be able to do that with intent is a pretty good goal to start with.
Yeah, and I think you kind of mentioned that artificial intelligence, automated decision making. I think the AI machine learning, research needs to figure out, how do I trust the AI and the machine learning constructs? And once they figure that out, we can figure out how to get that training or how to get that decision making automated into our pipelines. I think that's kind of the ultimate high maturity for DevSecOps. So with that, is there any last closing remarks anyone has before we turn it back over to Chris? No, so I think it's back to you, Chris.
Thanks, Tim, and thanks, Joe, Carol, and Natasha. That was a pretty interesting panel, and I know that there's a big push across the department to kind of adopt DevSecOps, and we have a big focus both on kind of the dev side and the security sides. And so really interesting panel, and thank you guys. Our last presentation of the day is by Dr. Jerome Uga. It's safety analysis and fault detection, isolation, and recovery synthesis for time-sensitive cyber-physical systems. Dr. Uga is a expert in systems modeling and kind of the verification and analysis of those systems, including work in AADL. And I'm really excited to kind of hear this future work of his. So thanks, everybody.
Thank you.
Thank you.
Hi, my name is Jerome Hug, and I'm the PI of the SAFER project. In SAFER, our team of SEI researchers, seconded by a group of researchers from Georgia Tech, is investigating the topic of increasingly autonomous cyber-physical systems. For those systems, AI engineering delivers the promises of fresh breaths, bringing new functions, new capabilities for advanced controls, situational awareness, or decision-making capabilities. But at the same time, our fear is that this fresh breeze may be coming from an iceberg, and indeed, those AI functions make it harder to demonstrate the safety of the system, to assure it. If we cannot address this issue, we may be forced to perform longer V&V processes, or we may experience a distrust in the system by its user, and ultimately the capability may not be deployed. So in SAFER, we aim to address this issue by delivering advanced safety analysis techniques to implement software bricks, fault detection, isolation, and recovery policies that will make sure that any error in the system will be properly detected and mitigated before becoming a threat to the system. And indeed, if we consider a typical scenario for an autonomous cyber-physical system, like a UAV patrol, at the very top level, this system will need to find and detect intruders, if any. We'll be able to recognize threats. But for that, we have to understand the concept of operation of a system. Let's say a factory with slow-moving parts. That system will have to operate in both closed and open areas with different environmental conditions like wind, lighting conditions, if not rain. It will have to execute tight maneuvers to enter and exit buildings, and of course we need safety margins to avoid damages. This system is also autonomous in the way it will make decisions and also in which it will interact potentially with human operators. The key research question behind this type of system is how can we guarantee that the system is safe to operate and will operate safely? In order to do that, as we are building and delivering the system, not only do we deliver the UAV ready to fly, but we also deliver an argumentation that this system is safe to fly and will fly safely. This argument is, if we express it in plain English, an argument that claims that the system is safe because it does such and such mission as collection of requirements that are implemented by an architecture and collection of software code, and that V&V activities demonstrate strict conformance to the element above. Furthermore, that the system can be operated safely and that in the event of hazard of threats, then those events are can be properly monitored and ultimately mitigated. To build this argument, we need a convergence between multiple teams: system engineers, cyber-physical system engineers, software architects, and embedded system architects. That they will build together a collection of models, concept of operations, requirements model. They will execute hazard analysis and derive an architectural description of the system and then implement it as code. In SAFER, we are building a comprehensive approach that will combine model-based system engineering and safety assessment. And for that, we'll work on 3 tracks. Define architectural patterns for fault detection, isolation, and recovery. tool support in order to understand the impact of this fault detection, isolation, and recovery policies on the behavior of system, and finally, extensions of existing tool sets so that we can produce automatically an argument that will articulate all those artifacts that are produced by those various engineering processes. But we don't want to generate another boilerplate pipeline. What we want is to bring additional engineering rigor, assume guarantee type of reasoning. Let's say, for instance, that assume that we know something about operational hazards, that we know faults or vulnerabilities on sensor actuators, timing anomalies, or AI function misbehavior. Basically, all the elements that may contribute to an unsafe scenario. Then we want to be able to guarantee that a candidate architecture will properly mitigate faults, both at design time, but also at implementation time, and finally at runtime. And for that, we developed 3 contributions. First off, fault taxonomy and guidelines for selecting fault detectors so that engineers will know precisely which policy are relevant for addressing a particular threat in their scenario. A mechanized semantics of architectural descriptions of a cyber-physical system so that we can simulate, model checking, or even prove some properties on a system. And finally, a way to derive a safety argument from all those models so that they can be reviewed by certification authorities. Let's start with the first contribution, which is how can we select the rightmost fault detection, isolation, and recovery, or FDIR, policy for a particular system. From an architectural perspective, the cyber-physical system will interact with an environment through sensors that will bring information so that the system can build a representation and abstraction of an environment. AI or ML functions will operate on those elements and execute algorithms for predicting, inferring, or optimizing some parameter of the system. And from this, make a decision and perform a basic action that will, again, impact ultimately the system again. There is a dual challenge here in that, first off, we want to make sure that the architecture can mitigate any erroneous inputs that will feed those learning-enabled components in terms of timing, loss of timing reference, in terms of inconsistent value. And conversely, we want to make sure that AI/ML functions will not misbehave, that will not trigger wrong scenarios in the system. And for that, we need, again, runtime assurance capabilities, fault detection capabilities. In order to capture all those elements, we need a baseline to model our system. And we selected the AADL language. AADL is the Architecture Analysis and Design Language. It is an SEI international standard that provides a mean, first off, to capture a design and then to execute analysis or even code generation, and to produce evidences for specific questions you may have on your design. Like, for instance, performance analysis, timing analysis, safety analysis, but also to perform model review for specific quality attributes and ultimately generate an assurance report out of those elements. AADL provides foundation for a lot of elements, and for safer, we are interested in safety. For that, what we need in order to assure our increasingly autonomous cyber-physical system is a way to capture the fault scenarios in a system. Notionally, this AI function may receive data from the environment, take a decision, and act on it. Pragmatically, what it means is that some data is processed by this platform and may be subject to specific risk, like, for instance, data tampering, the loss of a reference point due to a sense of fault or attack, a loss of a timing reference because of latency and jitter or timing violation in system, and of course all type of other typical faults that may happen, like a defect in a propeller, a defect in a sensor. All of that can be properly characterized using the AADL EMV2 fault taxonomy. The EMV2 fault taxonomy provides a dictionary of all the faults that may arise in a system with their mathematical description and a complete understanding of what it means, for instance, to have a value error versus having a timing errors. From those premises, we were interested by the following question. Can we first off capture a typical fault scenario for AI systems, and then can we select the rightmost detection mechanism? There is a huge literature on those topics, and so we need to organize it. We started by defining a decision procedure using the MV twofold taxonomy as a pivot. The basic idea is the following. For a specific scenario, we may derive what is a set of errors that it produces and isolate them and define them properly. Similarly, for a set of existing detection algorithms, we may define the set of error classes that are sensitive to timing, value, omission, etc., etc. And from that, we make the claim that a detector is efficient if the set of errors that it may detect contains a set of errors that can be produced. Behind that, what we have developed with Georgia Tech is a survey of fault detectors, a set of mappings for a collection of fault attack scenarios to detection mechanisms. And this way, we bring to designers a rich set of guidelines so that from their description of a fault or attack scenario, they may derive the rightmost fault detection algorithm. Furthermore, as we are investigating the topics of the impact of faults on system, as I said, we have to make sure that an architecture does not impact too much AI functions. A typical example is reinforcement learning controllers that will control the trajectory of vehicle. The architecture may induce delays or jitters as clock offsets because of the time it takes for data to flow from sensors to CPUs. What we demonstrated with Georgia Tech is that if clock offsets are bounded, then the reinforcement learning controller may still converge. It may be less efficient than in the pure theoretical case of no clock offset at all. But we demonstrate that if those clock offsets are bounded, which is something ADL can help demonstrating, then the system may converge. Simulation results also show the limits in offsets that ensure convergence. If we go beyond those limits, the system is basically impossible to control. With those two elements, we contributed to fault detection, isolation, and recovery as foundation for safety. We have defined guidelines to go from a fault scenario for an AI system to the selection of the fault detection, isolation, and recovery principles. Also, we have demonstrated that there exist safety margins an architecture should demonstrate in order for AI functions to be efficient. But that's high-level considerations. We need to go further and understand more precisely, more pragmatically, what is the impact of AI functions on the architectural system. And for that, we need to revisit the way we analyze the system. If we look at ADL, for instance, but it's the same for any standard, be it ADL, SysML, UML, etc., you will find in a document a collection of definitions, what is your component model, consistency rules that will make a model valid, collection of property sets, basically attributes that will help you to configure a system. A tool will generate an internal representation of those elements and define, for instance, a declarative model, an instance model that will help you to go further and extract information so that you can perform scheduling analysis, static security analysis, etc. And if you're interested in behavioral properties in order to perform simulations or model checkings, you can add those elements as additional definitions. For instance, what is the state machines attached to your classes of components? What is the port-based communication semantics of a system? And again, you can derive behavioral models that will be suitable for model checkings on simulation. However, there is a paradox here in model-based techniques in that we claim that model-based approaches are better than document-based, but at the same time, the semantics of a model itself is described as a document. Therefore, it is prone to interpretation errors. To address this issue, we move a little bit further and say, okay, can we define as a model the semantics of ADL in our case? It will act as a reference for other tools, but also it will improve the standard itself by eliminating corner cases. Our contribution here is a mechanization of ADL using the COC interactive software improver. Through this mechanization, released as a software artifact, we capture the static and dynamic semantics of ADL along with configuration through attributes defined as property sets. How does it work? First off, we import ADL model serialized in JSON as a collection of COC data types. Those COC data types are variants of, or interpretation, if you will, of the ADL metamodel. This data type is properly typed by typing rules that will define basically what is legal from a typing perspective, what is legal from a consistency perspective. So as by defining those well-formless rules, we can assert that a model is correct with respect to the ADL standard. Furthermore, we have defined and implemented an operational semantics of ADL. Basically, the set of rules that will tell you how to execute a model. From those elements, you can perform proof or model checking or simulation of an ADL model. And at the end of the second year of SAFER, we delivered 3 illustrations of those capabilities. First off, a complete definition of ADL as a set of COC data types and legality rules. Simulation capabilities so that you can simulate an ADL model by mapping it to the dev's formalism. We can perform scheduling analysis using the Prosa library, and currently under development, fault propagation and analysis of ADL model, again, mechanized in COC. So as we conclude those 2 contributions, basically our goal was to provide a way to build evidences that our system is safe. First off, at the system engineering level, how can we select the rightmost fault detection, isolation, and recovery policy? And second, how can we validate that the integration of this FDIR component in the architecture of the system is safe? And for that, we mechanized the ADL language so that we can understand very precisely how the system will behave. Those elements are providing evidences that must be combined together as we are building the final argument for the safety of our system. And for this, I will leave the floor to my colleague Keaton Anna that will tell you how we extended OSAT to generate argument in the goal structuring notation standard.
Thank you, Jerome. So with this project, we took a requirement specification language and mapped it to a popular safety case argument format. So our hope is that this will give developers the freedom to create architecture models using ADL and also benefit from ELISA's requirement verification and OSATE's built-in analysis. And we're going to take all of these existing inputs to generate a clear and concise goal structuring notation argument. So goal structuring notation is a graphical safety case argument format. It has 6 core elements: goal, solution, strategy, context, assumption, and justification. A goal element is essentially just a claim. These claims are broken down using strategy nodes, and then once that claim is successfully broken down, you can use the solution node. The context, assumption, and justification are used to give more background for agencies that review your safety case. So we chose to use RecSpec because it is a highly capable requirement specification language. So as we can see here, we have the description for the requirement OE-IS-SR2. This just gives a quick breakdown of what that requirement is doing. Then we have the category keyword. This allows for you to group requirements together based on similar characteristics. Now if we take a look at EA-HS1, we can see that it also has the refines keyword. This allows for you to break down requirements until they are verifiable. Now to verify these requirements, we use the verified notation. Now this is a separate notation from the RecSpec language, but the connection between the two is easy to understand, as we can see that this claim is named EA-HS1, which is the same as the second requirement that we took a look at. So within the verify language, we have the rationale keyword, which is just used as kind of a description of what the verification activities are. And then we have the activities keyword. This activities keyword allows for you to call verification methods, which verifies that a requirement is met against the ADL model. So now we'll take a look at the mapping. So for each requirement, we use their description as a description for either a goal or strategy nodes. Each requirement is denoted as either a goal or strategy node based on its category. As I mentioned earlier, the refines keyword is used to break down goals, which then is able to be used as a sub-goal. For the rationale, we are able to connect that as a context node to its given strategy or goal node. And then for verify, we use its rationale as the description for a solution node. So we try to keep this as simple as possible. But our goal is to allow developers to use AADL and ELISA just as they normally would, and just be able to click one button to jumpstart their safety case creation. Now I'm going to send it back to Jerome to conclude the presentation.
As we are finishing year 2 out of 3 of the SAFER project, our team of SEI researchers can claim already a couple of contributions that may be relevant to your own project. SAFER objective is to extend virtual integration capabilities of model-based system engineering, aka shifting to the left, for the case of increasingly autonomous or AI-based cyber-physical systems. First off, we derived a set of guidelines so that you can go from a fault scenario to the rightmost fault detection, isolation, and recovery mechanism for your system. Furthermore, we are improving the VNV and simulation capabilities of cyber-physical systems by mechanizing the architecture, analysis, and design language in COC as a way to provide stronger results in the way you can analyze your system, for instance, for performance or for safety. Finally, we extended the report generation capabilities of the OZT toolchain so that you can generate GSN reports in addition to typical reports as part of the execution of your assurance process. If you are interested by any of those contributions, please reach out to our team, first off in the Q&A session that will follow, or directly through this address at info@sei.cmu.edu. Thank you.
Thanks, everybody, for that interesting talk. We're back with Jerome live, who's here for your kind of questions. I'll just kind of remind everybody, make this a challenge for him. He loves it. You post your questions to the kind of YouTube chat, the Discord chat. It'll be great. He's game for anything. And we already have one, so thank you. And I'll read it for you, Jerome. I know you've kind of already taken a look for it. Can you offer an opinion on what the human role regarding safety in an increasingly autonomous system should be? Is it monitor, analyze, confirm, direct, other? What should that look like in your opinion?
Well, it's a very broad question, actually. What we have to remember is that increasingly autonomous system is not just one monolithic class of system. It's a broad spectrum. And so for me, as a human in the loop means that first we have to understand what is the mission and basically what is the pace of the system. For this project, we are considering all type of scenarios. If we consider, for instance, UAV systems, and we are building one scenario for UAV patrolling a factory, for instance, this system will be highly autonomous, very few human in the place. And therefore, the human will be there mostly for monitoring and eventually for confirming that there is something suspicious or not. But it will be probably every minute, every 10 minutes, or whenever it's required. We may also imagine fully autonomous systems, for instance, long-range UAV patrolling, for instance, monitoring some electricity grid, as you may imagine. For those, we may expect fully autonomous behavior and very few human interactions. So I guess it really depends on the type of missions and I would say the balance between the capability to implement autonomous function versus the need for human to supervise or monitor them. It's really dependent on the type of system, I would say. It's hard to provide any form of definite answer.
So I'm going to pick at that a little bit,
Sure.
Right? And so, and I kind of want to bring it back to the modeling a little bit and what we're capable of kind of making assertions on. And so can you help me kind of bridge those? So is there a way to, what level of modeling or assurance capabilities kind of lead you to say, you just check it when something goes wrong type of scenario, very light monitoring, right? And assume that it's correct by construction almost, versus kind of that other end of the spectrum, which is direct. Do you have a feel for what level of modeling gets us there?
Well, the level of modeling will really depend on the type of properties you have to demonstrate on your system. And actually, the reason why we were interested in this particular question, this research question, is that if we start with the foundations, the architecture of the system, and we want to hook autonomous functions, if we don't trust the architecture, it means that we have to supervise it much more often. We will have to check periodically whether the system is still working and operating as expected or not. And so it is a reason why we're interested in this correctness by construction of ADL-like models and the way to simulate them, and also the reason why we mechanize its semantics in code, so that we can have a better control, a better understanding of the way it will behave. And on top of that, we will plug autonomous functions. And we worked with Georgia Tech to evaluate the level of, I would say, fidelity or the capability to detect misbehavior. And what we discovered is that this part is much more difficult because you need to quantify them in the abstract using some confidence metrics. And from that, what we may say is that the system may fail after 1 hour, may fail after 30 seconds, depending on the running scenario. And ultimately, it's a question between the system designer and the system operator. And it's very difficult to provide a strong option because we have to understand the operational context, and we need some expertise which are outside what we do, I would say, typically when we do MBSC. In my group, we are much more familiar with cyber-physical systems for which we can make definite answers. But as we bring autonomy, we're also bringing operational context. And so we need really to be able to engage with the final users to understand what level of risk he is willing to accept, what level of confidence he needs in order to operate the system. And that is opening all type of new challenges for us applying model-based systems engineering for those systems.
Well, that's interesting. I'm going to pivot a little bit and kind of go back to some other topics you mentioned in the talk, which is, can you tell us a little bit, why are the fault detection mechanisms so hard to implement? What confounds there?
Well, it really relates to the notion of risk that I was mentioning just before. If you want to implement a detection mechanism, first off, you have to determine what are the scenarios that may lead to those faults. And usually it's a collection of low-level signals. It may be a sense of failure or some additional latency in the system that will corrupt information flowing down from sensors to CPUs. And so it is difficult to implement those fault detection because to some extent we have to process an additional stream of data so that we can say, oh, this looks suspicious or this looks completely wrong. And to make this decision, basically you have to know what will be the ideal solution. So it means that in parallel, ideally you would have to run a digital twin of the system or at least some prediction algorithms to make sure that, yeah, the system is behaving as expected. And the trickier the fault scenario, the more complex this simulation that you have to run in parallel has to be. And so it's creating all type of new challenges because we have to implement very clever fault detection for those systems. And as they become more sophisticated, their test and evaluation is becoming increasingly complex. And so we are looking with Georgia Tech to qualify those fault detection in such a way that we can reduce those testing elements.
That's great. I had some other questions, but unfortunately we're out of time. And so Jerome, this is great work and really thank you for your time and, continue work on this. And I'm just going to poke one last question, even though I'm really out of time. This project has another year of effort in it, or is this right? Yeah.
Another year,
so
yes.
Another year. Okay. That sounds great. Thank you. Well, everyone, that wraps it up for today. I just kind of want to cap off the day and talk about what we've heard. I've struggled a little bit to kind of, bring all of the topics together, but, in talking with the presenters offline and kind of hearing about it, I will say, and I'll credit Jerome for this. One of the things we can say is it's really interesting if you look across this. It's a combination of modeling, but in underlying that modeling to make the impacts we want to make, it's really a bunch of applied math and how we're kind of doing that math. And as a Software Engineering Institute, as a DoD FFRDC, we're really focused on bringing value to the department, and so we're applying this in areas that make, how do we make secure, reliable, fit for purpose cyber physical systems? How do we make the software development process have security properties as well as deliver, software on time and in an affordable way in DevSecOps? How do we use game theory to kind of understand cyber risk? How do we make this modeling capability more available to people and lower the barrier to entry to use these? And then, kind of the last one, which was really the first talk we heard today, right? Kind of transformative gamification. One of the takeaways there is, while we, are using gamification to make it more engaging for users, in order to not just fall into the kind of, fun failure where it's fun, but it doesn't serve the purpose, we really need to understand human motivation, have a model for why people want to engage, and understand what they want to accomplish. And so what you're seeing across all of these efforts, and whether it be trying to improve the security of cyber systems, or it's trying to improve our ability to deliver kind of high quality software that really delivers improvements that are measurable and important for the department, whether it's really, can we get kind of soldiers and DoD personnel more engaged in training and in kind of doing exercises. It's really modeling and math that's enabling us to get there and make those improvements for the department. And it's kind of impacting across the board. I hope everybody has a chance to kind of think about that. Give me your thoughts and opinions. Would love to engage with you. Kind of all the presenters, all the projects would love to have more engagement with DoD. We would love to be able to kind of try these techniques out for you. And we're really excited about that. And I can only tell you, we've had the AI day. We did some kind of defense. Tomorrow's going to be more focused on kind of software systems proper. And we look forward to kind of seeing you there again tomorrow for the third day of our research review. Thanks everybody for staying tuned, and I hope you join us tomorrow. Thanks everybody.